Hello there. Welcome to my channel. I'm glad you're here. Maybe today felt heavy, or maybe you just like drifting off while thinking about stars and quiet cosmic mysteries. Either way, this is your time now. There is nothing you need to fix, nothing you need to solve. Just breathe in gently and let the day loosen its grip on you as we wander slowly into the universe. Imagine yourself lying somewhere comfortable, your body sinking a little deeper into rest with every breath. The edges of your thoughts begin to soften, like clouds fading into twilight. Above you, picture a wide, dark sky stretching out farther than anything you've ever seen. No rush, no noise, just a gentle, endless space, waiting for you to float through it. Tonight, we're going to wander across some of the universe's most relaxing ideas. We'll visit its age and beginnings, glide past lonely planets drifting through darkness, explore the thought of a cosmos that might breathe in cycles, and listen to the oldest light still glowing around us. We'll move slowly, thought by thought, like stepping stones across a calm, quiet lake. For a long time, astronomers have tried to answer a simple question that isn't simple at all. How old is the universe? The best estimate we have right now is about 13.8 billion years. That number comes from careful measurements of how fast space is expanding and from the faint afterglow of the Big Bang, the cosmic microwave background. It's as if we've checked the universe's clock by listening to its heartbeat and watching how fast everything is drifting apart. But even this calm, confident number has little ripples of doubt around it. Some observations of very old stars and ancient galaxies suggest that a few of them might be older than the standard age allows, at least on paper. It's like finding a few wrinkles on the face of someone whose birth certificate says they shouldn't be that old yet. Other researchers wonder if the expansion of the universe has always moved in the same way, or if dark energy, that mysterious force speeding everything apart, has changed its strength over time. None of this is a crisis. Most scientists still gently rest on that 13.8 billion year figure, like a comfortable pillow that fits just right. But the questions haven't gone away. They linger quietly at the edge of our understanding. Could the universe be older than we think? Did something subtle happen at the beginning that we're still missing? It may be that what we call the beginning is more like the beginning of a chapter than the first page of the book. As you breathe slowly, you can let that thought drift through your mind. A universe whose true story might be longer and stranger than the number on our cosmic calendar. Now let your attention drift away from the beginning of everything and move to something much smaller, yet just as haunting. Not all planets live in the warm, familiar light of a star. Some are completely alone. These are rogue planets, worlds that drift through space without a sun. No sunrise, no sunset, no familiar orbit, just endless night, broken only by faint starlight from far away. Many of these planets probably formed around stars, just like our own world, but were later thrown out by gravitational chaos, pushed away during the restless early dance of their solar systems. Others may have formed on their own, more like failed stars than traditional planets. However they were born, they now wander the galaxy in silence. Cold, dark, and nearly invisible, they can only be noticed if they briefly pass in front of background starlight or glow very faintly in infrared. There may be billions of these loners in the Milky Way, perhaps even more than the number of stars. Each one is a whole world with mountains that never see dawn and skies that never brighten. Imagine standing on the surface of such a planet. Above you, the sky is a dark ocean, pierced only by distant stars. No familiar sun to mark your days. Time would feel like one long, gentle night. These worlds are not dramatic. They don't roar or blaze. They just drift, quietly, in the vast black between everything else. As you breathe in and out, you can picture them gently gliding through the dark, like stones sinking slowly through still water. From these lonely planets, let your mind pull back again to something even larger. the entire universe, and the way it might live, die, and begin again. In the standard story, the universe began with the Big Bang and has been expanding ever since, its galaxies slowly moving farther and farther apart. If nothing dramatic changes, that expansion may continue forever, leading to a future where everything is cold and spread out, a quiet, thin darkness. But some scientists imagine a different kind of story. In these ideas, the universe may move in cycles, a great expansion followed by a slow collapse, ending not in silence, but in a kind of reset. After growing for eons, the universe might reach a turning point, begin to contract, and eventually squeeze back into a dense, hot state. From there, it could bounce, expanding again into a new cosmic chapter. Not a replay, but a new round, with new galaxies, new stars, perhaps new laws or patterns. The observable versus entire universe, what we see and what lies beyond. When we look up at the night sky, we often imagine we're seeing the whole universe spread out before us, every star, every galaxy, every shimmering thread of cosmic light. But the truth is softer, stranger, and far more comforting than that. We are not seeing the whole universe. We are seeing only a small bubble of it, the observable universe, a gentle sphere of light wrapped around us like a cosmic lantern. This bubble isn't defined by what exists. It's defined by what light has had time to reach us. The universe has been expanding for 13.8 billion years, and light travels at a constant speed. Together, these limits form a boundary around us. Beyond that boundary lies everything we cannot yet see, simply because its light hasn't arrived. The observable universe is vast, about 93 billion light years across, but it is only a fraction of the whole, a drop of light in an endless cosmic ocean. Imagine standing on a beach at night. The waves in front of you glow under the moonlight, but the rest of the ocean stretches into darkness you cannot see. You know the water continues, but it vanishes beyond the horizon. That's how astronomers feel when they look into deep space. We see the glowing waves. We know there is more. We just can't see beyond our horizon. The boundary of the observable universe isn't a wall. It's a horizon of light, soft, fading, shaped by time itself. Inside this bubble, galaxies spin, stars burn, planets orbit, nebula flourish. Everything we have ever observed lives within this sphere. Every telescope image, every star map, every cosmic discovery belongs to our side of the horizon. But the entire universe stretches far beyond it, deeper than distance, older than our sight, unfolding into regions we will never reach. What lies beyond? The answers are both humbling and strangely comforting. Some scientists believe the universe extends infinitely, an endless web of galaxies beyond count, repeating in patterns so vast they never truly end. Others imagine the universe as finite but unbounded, like the surface of a sphere, without edges, curving softly into itself. And then there are the theories that the universe may be just one part of a grander multiverse, like a bubble floating in a sea of countless other bubbles. But no matter which picture is true, one thing is certain: the part we can see is only a small chapter in a much larger cosmic story. As you breathe gently, imagine yourself floating at the edge of the observable universe. Not a real boundary, but a place defined by time and light. Ahead of you lies darkness, not because nothing is there, but because its light is still traveling through the endless night. Somewhere beyond that darkness, galaxies are forming, stars are shining, planets are orbiting suns we will never know. And yet, the universe quietly connects us all. Gravity stretches across these unseen realms. Cosmic expansion shapes both the visible and invisible parts. Dark matter threads into filaments that extend beyond our horizon. The entire universe moves as one, even if we can only witness a small part of the dance. One of the most soothing truths is this: the observable universe grows with time. Every second, light from more distant regions reaches us. every moment our cosmic horizon widens just a little. The universe reveals itself slowly, gently, patiently. But because the universe expands faster than light travels, some distant regions will always remain hidden. Their light will never catch up. Their stories will remain unspoken. And somehow, this makes the cosmos even more peaceful, knowing there are mysteries so far away that they will forever remain beyond reach. Imagine stars forming in a galaxy far outside our visible horizon. Their light will never reach us. Their planets will never be mapped. Their stories will never cross into ours. And yet, their existence does not depend on being seen. They shine quietly in regions of the cosmos untouched by our gaze. The universe does not need an audience. It simply exists in calm, eternal unfolding. Sometimes astronomers wonder whether the structure of the unseen universe mirrors the parts we can observe. Does the cosmic web extend forever? Do superclusters repeat in rhythmic patterns across unimaginable distances? Is our observable slice typical, or is it unique? We may never know. But it is the not knowing that makes the cosmos so soothing. The unseen universe is a reminder that mystery is not a flaw. It is a feature, a quiet invitation to wonder. As you drift deeper into this thought, imagine the observable universe as a glowing sphere around you. Inside it, the galaxies shimmer like scattered jewels. Outside it, endless possibilities stretch out, soft, silent, unreachable, like dreams just beyond memory. The visible cosmos is our window. The entire universe is the view we cannot yet see. And both are beautiful. Sometimes, when you stand beneath the night sky, looking at starlight that began its journey long before you were born, you can feel the gentle truth settle into your chest. We are all living inside a growing bubble of light, a small, warm island in an ocean too vast to ever fully know. And yet, in that smallness, there is comfort. In that bubble, there is meaning. Because the part we can see is enough to fill our minds with awe and our hearts with quiet calm. The universe beyond the horizon will continue its silent expansion, its unseen stars continuing to burn, its galaxies continuing to drift, its stories continuing to unfold with or without us. What we can observe is enough to understand our origins. What we cannot observe is enough to remind us of humility, and together they form a universe both intimate and infinite. As you breathe slowly, imagine drifting near that horizon, watching galaxies fade into soft darkness, knowing that beyond them lies a cosmos still dreaming, still expanding, still carrying secrets not meant to be solved, only felt. A universe seen, a universe unseen, a universe whole. The birth of the universe, the Big Bang and cosmic inflation. In the beginning, there was no beginning. No space to hold anything, no time to measure, no light to guide a wandering thought. Just a silent potential waiting in darkness too deep to imagine. And then, in a moment so brief it almost didn't exist, everything changed. Not with a sound, not with a flash, but with the quiet unfolding of existence itself. What we call the Big Bang wasn't an explosion in space. It was the birth of space. A soft spreading of the cosmos outward, like the first breath of a newborn universe. Imagine everything, every star, every atom, every possibility, compressed into a point smaller than anything the mind can hold. No edges, no borders, only a dense warmth humming with future worlds. And then gently but irresistibly, that point expanded. Space stretched open, time began to flow, and the universe entered its first moment of awakening. It wasn't violent, it was simply unstoppable. The cosmos bloomed like a cosmic flower, unfolding into a darkness that had never known light. For a fraction of a second, the universe grew faster than anything we can compare it to. Distances stretched beyond imagination, entire regions forming in less time than it takes a thought to appear in your mind. Scientists call this cosmic inflation, a period when space expanded so quickly it left the newborn universe smooth and quiet, the way a calm sea appears after a great tide has pulled away. And somewhere within that stillness, the seeds of the galaxies took shape, tiny fluctuations held in the fabric of space like faint ripples waiting to become something more. It's peaceful to think about. The universe beginning not with chaos, but with possibility. A calm expansion that set the stage for everything that would one day shine, drift, or dream. And as you picture that early moment, another thought drifts through the silence. If the universe began in perfect darkness, how did it know to create light? The first moments after the Big Bang were filled with energy, with particles dancing through a soft, hot glow. But nothing yet resembled stars or galaxies. The universe was a warm mist, quietly cooling as it stretched. Protons, neutrons, and electrons drifted through a haze too dense for light to escape. It was a cosmic womb, cradling the ingredients of what would someday become suns and planets and living worlds. As it expanded, the universe cooled, the way a warm breath fades into the evening air. Tiny particles joined together into the first simple atoms, mostly hydrogen, a little helium, and the faintest trace of lithium. These atoms floated freely in the widening space, waiting for the forces of gravity to gather them into the shapes we know today. Everything was quiet, everything was patient, and the universe was still young, still learning how to shine. If you could drift back to that moment, back to the earliest seconds of creation, you would find yourself in a world where time barely had meaning. Space was stretching faster than light could travel, smoothing out every rough edge, leaving behind a gentle uniformity that still echoes through the cosmos today. And somewhere inside that expanding softness, a question would whisper to you. What might the universe look like if inflation had stretched just a little differently? As millions of years passed, the warm fog thinned and cooled. The universe became transparent. Light, once trapped, was suddenly free to wander through space. That ancient light still travels now, a faint afterglow stretched into microwaves by the expansion of space. It's the universe's oldest memory, a soft reminder of the moment when everything changed from a glowing cloud into a canvas ready to be painted with stars. Gravity, patient and persistent, began pulling atomic clouds together. Small ripples from inflation became the scaffolding for galaxies. Over time, dense pockets formed, swirling gently as matter drifted inward. The first stars were still centuries of centuries away, but the blueprint had already been written in the quiet patterns of early space. There's something soothing in knowing that even the grandest structures began with tiny fluctuations, small differences in density carried forward through time. It makes you wonder softly, how many vast and brilliant things in our own lives also begin as barely noticeable ripples? The early universe had no stars, no planets, no galaxies, just a soft sea of atoms drifting through expanding space. But inside that simplicity was everything needed for complexity. Every heavy element that would one day form mountains, oceans, and living creatures was hidden in the hearts of stars that had not yet been born. The universe was preparing its future quietly, patiently, like an artist mixing colors for a painting no one has seen yet. As time unfolded, gravity gathered gas into dense knots, and somewhere within the darkness, the first stars ignited. Their light pierced the cosmic night, illuminating the universe for the first time. These stars were massive, hot, and short-lived, burning through their fuel quickly and seeding the cosmos with heavier elements. The universe was waking up, slowly and beautifully. But before any of that happened, before the first glow or the first galaxy, everything depended on that initial instant, on the Big Bang and the calm rush of inflation. That first breath of creation allowed everything else to unfold. And even now, billions of years later, the universe still carries the imprint of its birth. It can be seen in the background glow that fills all of space, in the distribution of galaxies across the cosmos, and in the quiet expansion that continues even now. When you look up at the stars, you're looking at the aftermath of that first moment. You're seeing light shaped by the earliest ripples of space. And in the soft stillness of night, it's easy to feel the echo of that long ago beginning, a reminder that everything we know arose from a moment of expansion, warmth, and quiet possibility. And as you breathe deeply, letting the universe settle gently around you, a final thought drifts in. If the cosmos began with a whisper of creation, how many more whispers are still unfolding in the darkness, waiting to be discovered? Dark matter, the invisible scaffold of the cosmos. There are things we see when we look into the night sky: glowing stars, drifting nebulae, great spiraling galaxies. And then there are things we feel without ever being able to touch or witness them directly. Dark matter belongs to that second world, a quiet presence woven through the universe like invisible threads holding everything together. You cannot see it, you cannot hear it. You cannot shine light on it. And yet, without it, the cosmos would not exist in the shape we know. Galaxies would unravel, stars would drift apart, and the universe would dissolve into scattered light. Dark matter is the silent architecture beneath reality, the scaffold upon which galaxies assemble themselves. Imagine walking through a vast cathedral long before dawn. The pillars are hidden in shadow, the ceiling lost in darkness, the air still and calm. You cannot see the structure holding the building upright, but you feel its presence everywhere, in the stillness, in the balance, in the quiet weight of the room. That is how dark matter exists in the universe, unseen but unmistakable. When astronomers first measured how galaxies spin, they noticed something strange. The stars on the outer edges moved far too quickly, as if held by a gravity stronger than what visible matter could create. According to physics, those stars should have been flung away like sparks from a spinning wheel, and yet, there they were, orbiting steadily, silently, refusing to drift into the abyss. Something was holding them in place. Something invisible. Something massive. That unseen mass became known as dark matter. Picture a galaxy curling through space like a glowing whirlpool, its stars sparkling like grains of sugar stirred into night. Around and between those stars lies a vast, unseen halo. Not a ghostly fog, not a shadowy fluid, but something much more subtle, a gravitational presence that wraps the galaxy in a gentle, unseen embrace. Dark matter doesn't interact with light, doesn't reflect it or absorb it. To electromagnetic waves, it may as well not exist at all. But gravity feels it, and gravity reveals its shape as surely as wind reveals the shape of an invisible mountain. If you closed your eyes and let your imagination drift, you might picture dark matter as a kind of cosmic net stretched across the universe, not woven from threads, but from gravity itself, forming a delicate but immense framework that guides the flow of galaxies. This unseen net is called the cosmic web, an unimaginably large network of filaments and nodes shaping where galaxies form and how clusters grow, and the universe, even now, is following its outline, building itself on an invisible foundation. It's a soothing thought, in a way, that something can be essential, powerful, and ever-present, without needing to be seen. Dark matter gently anchors the universe, like roots beneath a forest. Without those roots, trees would topple in the slightest wind. Without dark matter, galaxies would spin themselves apart. But with it, the cosmos stays balanced, steady, allowed to grow into the breathtaking shapes we see today. Scientists estimate that dark matter makes up about 85% of all matter in the universe. That means everything we can see, stars, planets, nebulae, our entire Milky Way, and every glowing point in the sky, makes up only a teeny portion of what truly exists. The rest is quiet, invisible, a hidden mass surrounding you even now as you breathe, passing effortlessly through your body without a sound, without resistance, without leaving a trace. You've never touched dark matter, but dark matter has always touched you. Even on Earth, billions of particles of it drift through our planet every second, like a soft rain of unseen mass falling silently through stone and air and living beings. It doesn't collide with atoms. It doesn't disturb them. It simply continues on its way, indifferent to barriers, following paths shaped by gravity alone. There's something calming about imagining yourself as part of that flow, connected not only to the earth beneath you and the stars above, but to the unseen matter drifting through everything, binding the cosmos together in quiet unity. As you picture those invisible particles drifting through the universe, a gentle question rises. How much of reality lies beyond the reach of our eyes, waiting for us to sense it in a different way? Scientists around the world have built experiments deep underground, in silent caverns beneath mountains and deserts, waiting for a single interaction, a single spark between dark matter and ordinary matter. Most experiments have seen nothing, just quiet, just patience. But every so often, faint hints appear, not proof yet, not certainty, but whispers, as if the universe is offering clues in its own time. Some theories imagine dark matter as particles, tiny, timeless, barely interacting. Others see it as waves, fields, or subtle distortions in space that move like a tide. And still others suggest entire families of particles hidden from us, a shadow world overlapping ours, influencing our universe without ever stepping fully into the light. We don't know yet which of these visions is true, but the search continues with a kind of cosmic devotion. And in the meantime, dark matter continues its quiet work. Clusters of galaxies gather around great wells of dark matter, bending light as it travels across cosmic distances. This bending creates arcs, halos, and strange distortions in the sky. Gravitational lensing, a soft, silent fingerprint left by something we cannot see. It's almost poetic that dark matter's existence is revealed not by its presence, but by the curve of starlight passing near it, like wind revealing the shape of an invisible hill. If you were floating at the edge of the universe, watching galaxies sway and drift like lanterns in a slow-moving river, you would notice their motion guided by something unseen beneath the surface. Whole superclusters move as if pulled along vast gravitational pathways carved by dark matter. The cosmos flows along these paths the way water follows the shape of a valley, quietly, inevitably, beautifully. And somewhere within that thought, a softer one arises. How much of your life is shaped by unseen forces too? Gravity, memory, hope, the quiet pull of things you cannot fully name? The universe is not made only of what is visible. It is shaped by what is hidden. And perhaps there is comfort in knowing that even the largest structures in existence rely on something invisible, something gentle, something quiet to hold them together. Dark matter may be a mystery, but it is also a reminder that the unseen can be powerful, that the quiet can shape the world, and that reality is deeper, softer, and more expansive than the light alone can reveal. And as you breathe, letting your thoughts drift like galaxies along those invisible filaments, the universe feels just a little larger, a little calmer, a little more connected. Dark energy. Why the universe keeps expanding faster. There is a quiet pressure woven into the fabric of the cosmos, something so gentle and so vast that it pushes entire galaxies apart without making a sound. You can't see it. You can't touch it. But with every passing moment, it stretches the universe a little wider, like a soft breath expanding an endless chest. This presence is called dark energy, and it is the most powerful, most mysterious force the universe has ever known. For most of cosmic history, scientists believed gravity was the sculptor of everything. It gathers stars, binds galaxies, and pulls galaxies into clusters. Gravity is the universe's great gatherer. So naturally, we assume that over billions of years, the expansion of the universe must slow down, gently, patiently, under gravity's steady pull. But reality whispered a different story. When astronomers observed distant supernovae, tiny flickers of light billions of years away, they expected to see a slowing universe. Instead, they saw the opposite. The expansion wasn't slowing, it was speeding up, as if some unseen force were pushing everything outward, stretching space more and more with time. This discovery was quiet but earth-shattering. It meant the universe was not drifting gently apart. It was accelerating into the deep, and the cause of this acceleration became known as dark energy. Imagine space not as empty air, but as a fabric, soft, flexible, gently humming. Dark energy is like a tension inside that fabric, an energy built into the structure of space itself. As the universe grows, more space appears, and with it, more dark energy. More dark energy, more expansion. More expansion, more space. A loop that continues, silent and unstoppable. It's calming to think about in a strange way. The universe expanding, not because of explosions or violence, but because of a soft, pervasive pressure, as gentle as a rising tide. If you were drifting far beyond the Milky Way, floating in calm darkness, you would witness galaxies sliding away like lanterns, carried by an invisible current. Their motion wouldn't be frantic. It would be slow, patient, a graceful drifting, guided by dark energy's subtle push. And somewhere in that drifting stillness, a quiet question rises. How can something we cannot detect directly shape the entire fate of the cosmos? Dark energy makes up nearly 70% of the universe. That means most of the cosmos is not stars, not planets, not galaxies, but this calm, invisible pressure. It saturates every corner of existence, between galaxies, inside clusters, even in the quiet space around you right now. It doesn't bunch up like matter. It doesn't form structures. Instead, it remains smooth, evenly spread, always present, always expanding space itself. In the cosmic sense, dark energy is like a soft breath that never fully exhales. Scientists still don't know exactly what dark energy is. Some think it's a property of space itself, a cosmological constant, a steady, unchanging energy woven into the geometry of the universe. Others imagine it as a dynamic field, similar to an ocean of invisible waves flowing through existence. There are theories that dark energy could even interact with dark matter in ways we can't yet measure, the two unseen realms quietly shaping the visible one. But here, in this gentle moment, the specifics aren't what matters. What matters is the feeling of the universe continuing to expand, softly and endlessly, reaching outward into more of itself. And as galaxies drift farther away, their light stretches, turning redder and fainter. Over unimaginable timescales, the night sky will grow quieter as distant galaxies slip beyond the cosmic horizon, moving faster than their light can ever reach us. Not because they're speeding through space, but because space itself is stretching between us. It makes you wonder, how many things in life drift apart not because they move quickly, but because the space between them quiets and widens? Dark energy teaches us that separation can be gentle, that distance can grow softly, that expansion doesn't need noise to be profound. In the far future, trillions of years from now, the universe will be much emptier. Galaxies will stand alone in vast, dark spaces, islands drifting silently in an expanding ocean. Their neighbors will fade from view, not gone, just unreachable, their light stretched beyond forever. And yet, this isn't sad. It's peaceful. The universe is not collapsing in chaos. It's expanding into calmness, becoming softer, quieter with time. like a deep breath spreading gently through eternity. As dark energy pushes outward, it creates room for stars to burn, planets to orbit, and stories to unfold. Space grows, time lengthens, possibilities widen. Without dark energy, the universe might have collapsed long ago, folding into darkness before galaxies had time to shine. But instead, the cosmos breathes outward into a soft, expanding tomorrow. If you were to imagine dark energy as a presence, it would feel like a whisper, one that doesn't need to be loud to shape everything. It doesn't push galaxies violently. It simply widens the stage on which they drift. It doesn't hurry the universe. It guides it gently along a path of endless unfolding. And as you let this idea drift through your thoughts, a soft curiosity emerges. If the universe is expanding faster, what does that say about the nature of time itself? About the future we cannot yet see? About the vastness still waiting beyond the horizon? Even now, scientists are searching for answers, using telescopes that stretch their vision to the edge of the observable universe. They measure cosmic ripples, the glow of early light, the faint bending of distant galaxies. And in every observation, dark energy hides in the patterns, never visible, always present. It is the universe's quiet conductor, guiding the rhythm of expansion. And in this quiet moment, you are part of that rhythm too. Your atoms were born from stars shaped by gravity, held inside a universe expanded by dark energy. You exist in the space it creates. You breathe in the time it stretches. And as you sink deeper into calm, you drift with it, gently, endlessly, across the expanding sea of existence. Black holes, formation, event horizons, and Hawking radiation. There are regions of the universe where gravity becomes so deep, so silent, and so absolute that nothing, not even light, can escape. These are black holes, the quiet engines of the cosmos. Mysterious, dark, and yet strangely elegant, they sit at the centers of galaxies and drift through the night like shadows made of gravity itself. And though they are invisible, their presence shapes the stars, bends time, and whispers the story of cosmic transformation. A black hole begins as something familiar, a star. Not an ordinary star like the sun, but a giant, a massive, brilliant furnace that lived fast and burned fiercely. For millions of years, this star shines with relentless energy, holding itself up against gravity through the power of fusion. But eventually, even the greatest stars run out of fuel. And when the fusion stops, gravity wins. The star collapses inward, folding into itself with unimaginable force, compressing matter so tightly that no known structure can withstand it. In that collapse, a new object is born. Not a star, not even matter in any normal sense, but a point of concentrated gravity, wrapped in darkness. What remains is not the star itself, but its memory, its mass, its gravity. The star dies, and the black hole awakens. Imagine standing far away from a newly formed black hole. You would not see a solid object. Black holes are not spheres of dark matter. They are regions of space where gravity has hollowed out a well so deep that nothing can climb out. The boundary of this well is called the event horizon, a soft, perfect sphere marking the point of no return. Once anything crosses it, light, dust, stars, even time, it cannot escape. The event horizon is quiet, perfectly smooth, perfectly calm. If you drifted toward it, you wouldn't feel a barrier. You wouldn't see a wall. You would cross into the region beyond the reach of all possible paths, back home without a sound. A black hole doesn't pull you in with violence. It draws you in with inevitability. And inside, physics grows quiet. Equations tremble. Space and time begin to trade places, folding inward in a direction that no longer exists outside. At the center lies the singularity, a point where density becomes infinite and our understanding of reality softens into mystery. No telescope will ever see it. No light will ever escape its silent core. It is the deepest shadow in the universe. Yet black holes are not monsters. They are sculptors. Their gravity organizes galaxies, steadying the swirl of billions of stars. At the heart of the Milky Way sits a supermassive black hole, 4 million times the mass of the Sun. It rests quietly, holding the galaxy together with a calm central pull. Without such giants, galaxies might not form the beautiful spirals we see at all. Black holes bend light as it passes near them. They twist the paths of stars, shape the motion of gas clouds, and send ripples through the fabric of space-time. These ripples, gravitational waves, carry the faint echo of collisions that happened billions of years ago, long before Earth existed. When two black holes spiral together and merge, they send out a final whisper, a chirp in space-time that washes across the universe. And now, with delicate instruments, we can hear them, faint, beautiful signals from invisible giants. If you imagine yourself drifting near a black hole, you might picture a swirling disk around it, bright, hot, luminous. This is the accretion disk, made of gas, pulled inward, and heated until it glows. It is one of the brightest things in the universe, shining even though the black hole itself remains dark. The contrast is soothing, a brilliant ring encircling a perfect silence. And yet there is an even stranger whisper woven into this darkness, Hawking radiation. Physicist Stephen Hawking proposed that black holes are not perfectly black. At the edge of the event horizon, quantum fluctuations flicker into existence, particle pairs born from the trembling vacuum. Sometimes, one particle falls in while the other escapes. To an outside observer, it appears as if the black hole is emitting a faint glow, a slow leakage of energy. Over unimaginable time, this radiation causes the black hole to shrink, quietly, gradually, like a glowing coal cooling in the darkness. A black hole, the mass of a star, would take trillions upon trillions of years to evaporate, far longer than the age of the universe. But even these giants, in the far future, may fade into nothing, dissolving into a final whisper of light. It's a gentle thought. Even the darkest things in the universe do not last forever. They transform, they release, they let go. Black holes also distort time itself. If you orbited one safely, time for you would slow compared to someone far away. Minutes for you could be hours or years for the rest of the universe. It's not science fiction. It's a measured, proven consequence of gravity. Black holes stretch the rhythm of time the way tides stretch the surface of the sea, smoothly, silently, irresistibly. There are even black holes that wander through space alone, drifting like shadows unanchored to any galaxy. Some were kicked out during mergers. Others formed from stars in lonely regions of space. No accretion disk, no glowing jets, just a silent traveler, invisible except for the gravity bending the starlight around it. And yet, black holes are not empty. They are stories. Stories of stars that lived and died. Stories of galaxies being shaped. Stories of time being stretched and light being bent, and gravity becoming so deep it becomes its own kind of existence. When you look at an image of a black hole, the glowing ring, the dark center, you are not seeing the hole itself. You are seeing light trying to escape, bent and twisted into a final embrace around the darkness. You are seeing the shadow, not the thing casting it, a silhouette of gravity. And as you let your thoughts drift across this vast idea, a calm realization settles in, that the universe holds both light and darkness in perfect balance, that the greatest mysteries are often quiet, and that even in the deepest void, there is beauty, soft, profound, and patiently waiting to be understood. Galaxies, their types, evolution, and mysterious cores. When you look into the night sky, you're not just seeing stars, You're seeing tiny fragments of a much larger tapestry, quiet threads in an ocean of light. Because beyond the single points that shine above you, there are structures so vast, so gentle, so filled with silent motion that they reshape the meaning of distance itself. These are galaxies, islands of stars floating in the dark sea of the cosmos. A galaxy is not a single thing. It is a family, a gathering, a slow swirl of gas, dust, gravity, and light, bound together in shapes that drift through space like cosmic lanterns. Some are elegant spirals, curling gracefully as if painted by a patient hand. Others are smooth ellipses, calm, rounded, ancient. Then there are irregular galaxies, scattered and jagged, like clouds caught in a cosmic breeze. Each type carries its own quiet story. Imagine standing far above the Milky Way, floating in a silence so deep you can hear your own thoughts echo back through time. Below you, our galaxy stretches out in a vast, luminous spiral, arms curling around a glowing center. Billions of stars shimmer like grains of golden dust. Rivers of dust clouds wind between them, dark and soft, like shadows resting on a luminous sea. This is home, a single spiral in a universe of countless spirals. Spiral galaxies are the dancers of the cosmos. They rotate slowly, their arms sweeping through space in gentle arcs. Stars form along those arms, bright and young, glowing like new embers scattered across the dark. These galaxies are alive in movement, always shifting, always creating. If you drifted through a spiral galaxy, you would pass through star nurseries, vast clouds where gravity gathers gas and dust into glowing newborn suns. Whole clusters would shimmer like fireflies in the night. Elliptical galaxies, by contrast, are ancient, round, smooth, and majestic. They carry the memory of long histories, stories of collisions, mergers, and quiet settling. Their stars are older, redder, slower. There are fewer gas clouds, fewer new stars being born. These galaxies are like cosmic elders, resting after a life of dramatic events, glowing softly with the calmness of age. Then there are irregular galaxies, messy, scattered forms that seem to defy patterns. They have no fixed shape, no symmetric arms, no balanced core. Instead, they drift through space like brushstrokes, left unfinished. Many irregular galaxies were shaped by encounters with neighbors, gravitational tugs that stretched them, bent them, and left them in forms both chaotic and beautiful. They remind us that even in the universe, not everything follows rules, and sometimes beauty comes from a lack of structure. But galaxies do not exist alone. They gather into clusters and superclusters, linked by long, invisible bridges of dark matter. These clusters drift through a larger structure called the cosmic web, the vast network of filaments that shape the entire universe. If you could see everything at once, all galaxies, all clusters, you would witness a pattern that resembles a neural network, glowing nodes connected by delicate threads of gravity. And yet, as grand as their structures are, the true mystery of galaxies lies at their centers. At the heart of nearly every large galaxy sits a supermassive black hole. Millions or even billions of times the mass of our sun, these silent giants anchor their galaxies with gentle, powerful gravity. Some are quiet, barely noticeable. Others feed on swirling disks of gas and dust, creating quasars, beacons so bright they outshine entire galaxies. Imagine drifting toward a galactic core. The stars grow denser, the light intensifies. A glowing ring of matter swirls around an invisible shadow, shining brighter the closer it gets to eternity. And in the center, that supermassive black hole waits, motionless yet shaping everything around it. Its presence governs the rhythm of stars, the structure of gas clouds, even the evolution of the galaxy itself. It's peaceful to imagine, in a strange way, that all galaxies, vast as they are, have a quiet heart. Galaxies also grow through encounters. When two galaxies pass close to each other, gravity stretches them into long streams of starlight called tidal tails. If they collide, their stars mostly pass through without touching, but their gas clouds crash together, triggering explosive waves of star formation. Entire generations of stars are born in the wake of such cosmic dances. And eventually, the galaxies merge into a new shape, perhaps a larger spiral, perhaps a smooth elliptical, perhaps something entirely new. Our own Milky Way is dancing too, slowly, patiently. It is drifting toward the Andromeda Galaxy. In a few billion years, the two will merge, not in violence, but in a slow, majestic blending. Stars will be thrown into new orbits, long rivers of light will stretch across space, and eventually, the pair will form a single larger galaxy, shining softly in a quieter, more open universe. Galaxies are not static. They evolve across billions of years. Young galaxies are messy, full of gas and bright blue stars. Mature galaxies are structured, balanced, and glowing steadily. Old galaxies fade, their star formation slowing, their colors deepening into warm reds and golds. And yet, no matter their age or shape, galaxies all share one thing: a slow, patient journey through the cosmos. They drift along the currents of dark matter, move in gentle arcs, gather companions, lose fragments, and shine with light that holds the memory of everything they've ever been. Their motion is almost relaxing, a slow ballet through time. When you look up at the night sky and see the faint blur of Andromeda, you are looking at light that began its journey 2.5 million years ago. That galaxy is drifting toward us even now, silently bridging the distance between two worlds. And somewhere in its glowing core, stars are living their quiet lives, unaware that someone on a distant planet is watching their ancient light. Galaxies remind us that the universe is not rushing anywhere. Everything unfolds slowly, softly, on timescales so large that even the brightest explosions feel calm when viewed from afar. And as you imagine these immense structures, spirals turning like cosmic flowers, ellipses glowing like ancient embers, irregular galaxies drifting like clouds, the universe feels just a little more peaceful, a little more patient, and a little more connected. Stars, life cycles. From nebula to supernova. Every star you've ever seen, every point of light shimmering softly in the night sky, began its life in darkness. Not the cold, empty darkness we imagine when we look up, but a dense, velvety cradle of dust and gas, hidden inside vast clouds drifting through galaxies. These clouds are called nebulae, and they are the birthplaces of stars. Picture a nebula as a slow, breathing creature, enormous and silent, stretching across light years. Inside it, tiny ripples of density drift like whispers, gathering matter grain by grain. Over millions of years, gravity begins its gentle work, drawing the gas inward, compressing it softly, folding it into shapes that grow warmer at the center. And then quietly, something extraordinary happens. A glow appears, soft at first like the faintest ember in a cold night. The core warms, brightens, and begins to shine. A star has been born. Stars live long, peaceful lives compared to ours. Their brightness steady, their rhythms calm. They are nuclear furnaces, fusing hydrogen into helium in an endless glowing heartbeat. The energy released pushes outward with just enough strength to counter gravity's quiet pull inward. This perfect balance can last millions or billions of years. And in that time, a star becomes a cosmic lighthouse, sending light across the dark vacuum, illuminating worlds and warming everything that circles around it. Our sun is one such star, ordinary, steady, patient. Yet even ordinary stars hold stories older than Earth itself. The light you feel on your skin each morning is the warmth of a star that has burned calmly for more than 4 billion years, holding our solar system in a delicate gravitational embrace. But not all stars are the same. Some are giants, blue-white titans burning 10,000 times brighter than the sun. They roar through their fuel quickly, living fast and dying young. Others are tiny red dwarfs, faint and cool, flickering softly for trillions of years. These small stars are the quiet elders of the universe, living far longer than any galaxy has existed so far. Imagine drifting through the cosmos, passing from one star to another. Each one has its own personality. Some are calm, glowing like soft lanterns. Some are restless, flaring with bursts of energy. Some pulse subtly, expanding and contracting like slow breaths. Some spin rapidly, turning their light into rhythmic flickers. And in their company, you would feel a gentle truth. Stars are not just points of light. They are stories written in fire. But every story, no matter how long or brilliant, must eventually change. As a star ages, it slowly runs out of hydrogen fuel. The outward pressure decreases, gravity begins to tighten its grip, and the delicate balance is broken. The core contracts, growing hotter, while the outer layers swell outward. The star becomes a red giant, its glow deepening into warm hues, expanding so enormously that it may engulf any nearby worlds. If you could watch this transformation from afar, it would look almost peaceful, a star stretching into its final luminous phase, breathing its last great breath of light into space. And when the hydrogen is gone and the helium begins to fuse, the star's fate branches into different paths depending on its mass. For stars like our sun, the end is gentle. They shed their outer layers into glowing shells of color, planetary nebulae, delicate and shimmering, like cosmic blossoms, drifting open in the dark. What remains at the center is a white dwarf, a small, dense core glowing faintly with leftover heat. Over billions of years, even that glow will fade, leaving behind a quiet, cold remnant. But for massive stars, those roaring giants whose hearts burn fiercely, the ending is far more dramatic. When they run out of fuel, their cores collapse in a sudden inward fall. And then, in the blink of a cosmic moment, the star explodes outward in a supernova, releasing more energy in a single instant than the sun will emit in its entire life. A supernova is not violent in the way we understand violence. Seen from a distance, it is soft, brilliant, breathtaking, a flower of light unfolding across light years, scattering elements into the cosmos. Every heavy atom in your body, oxygen, carbon, iron, calcium, was forged inside a star and released in such a cosmic exhalation. You are literally made of stardust, shaped by the quiet death of ancient suns. After the explosion, the core collapses into something new. If it's small enough, it becomes a neutron star, an object so dense that a teaspoon of its material would outweigh a mountain. Some neutron stars spin rapidly, sweeping beams of light across space like cosmic lighthouses. Some pulse, some crackle with magnetic storms. Others drift silently in the dark. But if the collapsing core is massive enough, something even deeper forms, a black hole, a region where gravity becomes a silent well, pulling everything inward, even time. And so the life of a star that began in darkness ends in a deeper darkness still, completing a cycle older than the galaxies themselves. Yet the story doesn't finish there. The material ejected from dying stars drifts back into space, enriching nebulae with heavier elements. Those nebulae form new stars, new planets, new possibilities. And somewhere in that endless, quiet recycling, life emerges. Every star that dies gives birth to the next generation of suns, worlds, and stories. The universe is not a sequence of isolated events. It is a gentle loop, a cosmic breath, inhaling and exhaling light. As you drift through this thought, a soft question forms. How many stars died to make the atoms that now breathe inside you? How many distant suns contributed to the quiet spark that allows you to dream? The answer is countless. You are made of many stars. You are the echo of constellations long faded. You are the continuation of starlight. Stars live. Stars die. Stars are born again. Their cycles are slow, calm, inevitable. And as you think of their gentle transformations, your mind begins to follow their rhythm, steady, peaceful, glowing softly through the dark. Exoplanets, worlds beyond our solar system, far beyond the familiar glow of our sun, past the planets we know and the quiet edges of the Kuiper Belt, there are worlds that orbit other stars, worlds we cannot see with the naked eye, worlds that drift in the soft radiance of suns we may never visit. These are exoplanets, planets beyond our solar system, each one a quiet possibility in the vast unfolding of the universe. For most of human history, people wondered whether other worlds existed. We had no proof, only imagination. The stars were distant lanterns, flickering in darkness, and we could only guess what stories they held. But now, with delicate instruments and patient observation, we know that exoplanets are everywhere. Nearly every star you see tonight may have planets circling it, each one carrying a unique, silent world of its own. Imagine drifting through the galaxy, moving softly from one star system to another. Around one star, you might find a world of deep oceans, shimmering beneath pale violet skies. Around another, a planet of swirling storms, its atmosphere glowing faintly like an ember in the night. There might be a frozen world with rings made of glittering ice crystals, or a molten planet so close to its sun that its surface glows like liquid metal. Each exoplanet is a different dream. The first exoplanets discovered were surprising. Some were hot Jupiters, giant gas planets orbiting so close to their stars that a year lasted only a few days. They raced around their suns at extreme speeds, their atmospheres puffed out by intense heat. No one expected such worlds. They forced us to rethink what a planet could be. Then came super-Earths, rocky planets larger than our own. Some may be warm and comfortable, with gentle climates and oceans that glow in starlight. Others may be harsh and volcanic, their surfaces cracked with rivers of fire. There are also mini Neptunes wrapped in thick atmospheres, lava worlds, glowing under their stars' relentless gaze, and rogue planets wandering the galaxy without a sun, drifting alone through eternal night. The diversity is endless. The creativity of the universe is boundless. But perhaps the most enchanting thought is this. Some exoplanets lie in the habitable zone of their stars, the gentle region where temperatures might allow liquid water to form. Not too hot, not too cold, just right for the delicate dance of life. Scientists search for these worlds with a kind of cosmic tenderness, listening for the faint dimming of starlight as a planet passes in front of its sun. That tiny shadow is a whisper across the void, a signal that another world is there. We measure its size, its orbit, even the composition of its atmosphere, all from light that has traveled across unimaginable distances. And yet, no matter how much we learn, the surface of these worlds remains peaceful and mysterious, untouched by our eyes. We don't know what their skies look like. We don't know how their winds move or what colors paint their horizons. But imagining them is a gentle journey in itself. Think of a world with twin suns setting over an ocean so calm it mirrors the sky. The light softens into gold and rose, casting shimmering reflections across waves that have never known a storm. Or imagine a planet wrapped in thick clouds of sapphire blue, where lightning pulses silently, illuminating hidden valleys far below. Picture forests of alien plants, their leaves glowing with soft bioluminescence, or plains of crystal sand that ring like bells when touched by the wind. The universe may hold worlds far more serene, far more strange, far more beautiful than anything we can paint in our imagination. Some exoplanets orbit stars much smaller and cooler than the sun, red dwarfs that burn dimly but last for trillions of years. These stars cast a calmer, softer light, turning the skies of their planets into shades of wine red or deep violet. If life exists there, it may grow under a quiet, steady glow, untouched by the harsh flares of brighter stars. Other exoplanets orbit large, hot stars whose light is intense and brilliant. Their skies might blaze with ultraviolet colors. Their oceans, if they exist, might glow a deeper shade than any on Earth. Their winds might move in gentle, slow currents shaped by long days and longer nights. And then there are tidally locked planets, worlds where one side always faces the star, bathed in perpetual daylight, while the other side rests forever in darkness. In between lies the Terminator line, a ribbon of eternal twilight where temperatures might be mild and soothing. Imagine standing there, watching a sun frozen at the horizon, never rising, never setting, just glowing softly through a sky that never fully turns to day or night. There is something calming about knowing that worlds like this could exist, worlds balanced between opposites, where life might move in gentle rhythms shaped by eternal dusk. As you drift deeper into the idea of exoplanets, another soft thought appears. Somewhere out there, perhaps on a distant world, a night sky might glow with colors we cannot name. Stars might shimmer through strange atmospheres. Moons might drift in slow, elegant arcs. And maybe somewhere, something is looking up at its sky, wondering whether other worlds exist, just as we do. In this cosmic exchange, we are both the observer and the observed, both the dreamer and the dream. We search for exoplanets not only to understand the universe, but to understand ourselves. Their existence reminds us that Earth is not alone, that our story is one among countless possibilities. Somewhere in the quiet expanse, there may be oceans warmer than our own, mountains taller than Everest, skies with constellations made of stars we've never seen, and maybe gently, softly on some distant shore, life breathes under alien suns. But even if we never reach those worlds, the knowledge that they exist brings a kind of peace. It widens the universe around us, makes the night sky deeper, and fills our imagination with endless quiet horizons. Every exoplanet discovered is a reminder that creation is vast, generous, and full of wonder. And as you let this thought settle, you drift into a feeling that is both small and infinite at once, the feeling of belonging to a universe filled with worlds beyond counting, each one carrying its own whisper of possibility. Cosmic background radiation, the universe's faint afterglow. Long before stars existed, before galaxies swirled into their elegant shapes, before planets formed and cooled, there was only a warm, glowing universe filled with light too bright and dense for anything to escape. For the first few 100,000 years after the Big Bang, the cosmos was a soft, hot fog, a glowing ocean of particles dancing so closely they could not let light travel freely. Photons bounced around endlessly, trapped in a luminous haze like sunlight caught inside a thick cloud. And then slowly, gently, everything changed. As the universe expanded, that early glow cooled. Space stretched wider, the temperature fell, and particles finally drifted far enough apart for light to travel unhindered. In that moment, the cosmos became transparent, the fog lifted. Light was released to wander freely across billions of years. That ancient light still travels today, soft, cold, faint, but still present, like a memory the universe never let go of. We call it the cosmic microwave background, or CMB, a delicate afterglow filling every corner of the sky. You cannot see it with your eyes, but radio telescopes can. They detect this faint whisper of radiation, a soft blanket of microwaves stretched thin across space. It is the oldest light we can observe, and the most gentle. It comes from a time when the universe was less than 1% of its current age, the first visible moment in cosmic history. Imagine standing at the edge of a vast ocean at night. The waves roll in softly, carrying echoes from places far beyond sight. That is what the CMB is, a cosmic shoreline, carrying a whisper from the very beginning. If you could drift through space and collect this ancient light in your hands, it would feel incredibly cold, just a few degrees above absolute zero, but inside that coldness lies warmth from the past, a faint, faded echo of the time when the universe was glowing everywhere, equally, without galaxies, without stars, without dark stretches of emptiness. Just a smooth, shimmering fog of light. Today, the CMB looks almost perfectly uniform. Almost, but not quite. If you examine it closely, using sensitive instruments orbiting above Earth's atmosphere, you see tiny variations. Small ripples barely noticeable, only a few millionths of a degree warmer or colder than the surrounding glow. These ripples are the fingerprints of the young universe. They show places where matter was ever so slightly denser, places where gravity would eventually gather gas and form galaxies. Every galaxy, every cluster, every star that exists today can trace its origins back to one of these tiny ripples in the CMB. It's humbling to think that your entire existence, your world, your body, your thoughts, began as nothing more than a slight temperature variation in a sea of ancient light. Those ripples acted like seeds. Over billions of years, gravitational currents gathered matter around them, creating structures that grew slowly but surely into the galaxies we see now. Without those delicate imperfections, the universe would be an empty, featureless haze. No stars, no planets, no life. Perfection would have meant silence. Imperfection gave rise to everything. As you picture the CMB stretching across the sky, a soft, gentle question arises. How many hidden patterns reside in places we rarely look closely enough to notice? The CMB is not bright or dramatic. It is subtle, quiet, understated, like a whispered memory fading across immense time. But it contains extraordinary information. It reveals the age of the universe. Its shape hints at the geometry of space. Its ripples show how matter gathered. Its faint temperature reveals how the universe has expanded. It even tells us something mysterious. The universe is almost perfectly flat, not curved like a sphere, not shaped like a saddle, flat in the geometric sense. This hints that space on the largest scales is smooth, balanced, and stretched out far beyond what we can see. The CMB lays out that shape like a soft, cosmic map, and woven into this map is the faint signature of something even stranger. Acoustic waves echoing through the early universe. These were sound waves, not in the sense of music or wind, but pressure waves rippling through the hot plasma before light could escape. The universe, in its earliest moments, was singing, a deep, resonant hum shifting through temperature and density. When the fog lifted, these sound waves froze into place. What remains now is their imprint, a series of gentle rings spread across the cosmic background, a snapshot of the universe's first and only song. If you could listen to that ancient hum, stretched out by billions of years, it would be too low for human ears to hear, a cosmic lullaby drifting at frequencies more peaceful than silence itself. The CMB is also proof of something profound. The universe had a beginning. It is the afterglow of creation, the last light released from a young cosmos taking its first breath. Without this relic radiation, we would have no way of knowing what the early universe looked like. It is a photograph taken long before stars existed, a portrait of the cosmos as an infant wrapped in warm light. And the photograph is everywhere, in every direction, at all times, surrounding you gently like a soft cosmic mist. Even in the quiet of your room, even as you breathe, even in the dark between the stars, this ancient light fills space. It passes through you constantly, softly, unnoticed. You are bathed in the universe's oldest memory. As you drift deeper into this idea, the boundaries between then and now feel thinner. You begin to sense that time is not a straight line, but a long, unfolding story, with each moment carrying echoes of all that came before. The CMB is the opening chapter of that story, a gentle reminder that everything, stars, galaxies, life, grew out of a warm, glowing beginning. And somewhere inside that faint afterglow, the universe still remembers who it once was, the fate of the universe. When we look up at the night sky, everything feels timeless. Stars shimmer as though they have always been there. Galaxies drift silently, giving the illusion of a universe that moves but never truly changes. But the cosmos is not frozen. It is evolving, unfolding, moving through eras so vast that human time feels like a single heartbeat against eternity. Somewhere far, far into the future, the universe has a destiny, a gentle ending, a final chapter written by the quiet laws that guide everything. Scientists imagine several possible endings for the cosmos, different fates shaped by how space expands and how gravity pulls. None of them are violent to witness. They are slow, soft, drifting transformations that play out over trillions and trillions of years, long after the last star has faded. And as you let these possibilities float into your thoughts, the universe seems to breathe a little deeper, revealing its long, quiet future. The first possibility is the heat death of the universe, also called the Big Freeze. It begins with something simple: expansion. As space stretches, galaxies drift farther apart. Their light grows dimmer, stretched into longer wavelengths until it melts into the cold background. Stars burn their fuel over billions of years, glowing steadily until they have nothing left to give. The bright spirals of galaxies fade into darkness. The last stars flicker quietly and go out. Imagine a universe where the night sky no longer holds constellations, where galaxies that once glittered with billions of suns are now dark islands separated by distances too vast for light to cross. In this far future, even black holes begin to evaporate through Hawking radiation, shrinking over unimaginable timescales until they vanish in tiny flashes of light, gentle sparks disappearing into the quiet. What remains is a cold, silent universe filled with thin, drifting particles and fading radiation. No structure, no warmth, just a calm, endless stillness. Not tragic, not frightening, simply peaceful. A universe that used all its energy, spread it out evenly, and came to rest like a warm ember cooling in the night. Another possibility is the Big Rip, a fate shaped by dark energy, the mysterious force causing the expansion of the universe to accelerate. If dark energy grows stronger with time, its gentle push may not remain gentle forever. The expansion could become overwhelming, stretching galaxies apart faster and faster. Stars would drift away from each other, then planets from their stars, then atoms from each other, as space itself pulls everything wider. But if this fate comes, it would unfold gracefully over billions of years, so slowly that no sudden moment would break the calm. The universe would simply stretch until it is no longer recognizable, an infinite growing sea of space with fewer and fewer islands of matter. A soft unraveling, an ultimate expansion, a whisper that grows thinner until it fades into nothing at all. And then there is the third possibility, the Big Crunch. This fate imagines a universe not pushed apart forever, but slowed gently by gravity until the expansion stops. Then very gradually, everything reverses. Galaxies begin drifting toward each other. Vast cosmic distances shrink. Everything that was stretched becomes compressed. The universe warms as matter crowds closer, turning the quiet darkness back into a glowing, hot, vibrant state. Imagine the universe breathing in after breathing out for trillions of years. The stars grow brighter again as temperatures rise. Galaxies fold into each other, creating brilliant collisions. Space itself curls inward, and eventually, everything returns to a single point, a moment mirroring the Big Bang, but in reverse. A cosmic heartbeat, a cycle closing. If that were the fate, the universe might not end at all. It might begin again. Another burst of creation, another bloom of galaxies, another era of stars. A universe that dies only to be reborn, endlessly, like a cosmic tide. But what's most beautiful is this. Even though scientists study these possibilities with precision, we are still held in gentle uncertainty. The future of the universe is not fixed. It drifts with the unknown shapes of dark matter and dark energy. It unfolds according to laws we are only beginning to understand. And in that mystery, there is something deeply calming, because the end of the universe is so far beyond the reach of human time that our existence glows peacefully within its early chapters. Right now, the stars still shine, galaxies still swirl, light still travels. Everything you see in the night sky is part of a universe in full bloom. The cosmos is young compared to the ages that lie ahead, vibrant and full of structure. We live in a golden era, one where stars illuminate the dark, where planets cradle life, where galaxies paint the emptiness with graceful spirals of light. As you imagine the far future, you might sense a gentle truth forming. Every moment is temporary, but nothing is wasted. Every star that burns, every planet that dances, every atom that breathes, contributes to the larger story of a universe always in motion. And perhaps as the cosmos drifts toward one of its quiet endings, it carries the memory of everything that came before. Every glow, every sound, every spark of life. Maybe the universe itself holds onto those memories lightly, the way a dream lingers just after waking. Whichever fate unfolds, freeze, rip, or crunch, the end will not be sudden or harsh. It will be slow, measured, peaceful. A gentle unfolding across unimaginable time, a universe returning to stillness after an eternity of creation. And as you let your thoughts drift through these possibilities, you may find a strange comfort in all of it. The idea that even the largest, most mysterious thing we know follows a path of softness. That even the cosmos, in all its immensity, moves toward calm. Multiverse theories, parallel realities, and higher dimensions. There are moments when the universe feels almost too vast to comprehend, and yet scientists believe that even this enormous cosmos, the galaxies, the stars, the dark matter, the expanding space, might be only one chapter in a far greater story. The idea is simple but astonishing. Our universe may not be the only universe. It might be one bubble in a cosmic sea filled with countless others, each with its own laws, its own histories, its own quiet possibilities. This is the realm of multiverse theories, where imagination drifts gently into science and where the edges of reality soften into something wider and more mysterious than anything we can see. Imagine our universe as a delicate sphere, expanding outward like a soft glowing bubble floating in infinite space. Now imagine many such bubbles, each born from its own Big Bang, each drifting in an ocean beyond all observation. Some bubbles might be smaller, some larger, some older, some barely beginning. And the space between these universes, the multiverse, is silent and unreachable, a void so vast that even the idea of distance loses its meaning. If you could step outside our cosmos and look at it from a place beyond space and time, you might see a shimmering foam of universes, stretching endlessly in every direction. Some bubbles may brush against each other, their boundaries trembling softly. Some may remain forever alone, and somewhere among them, ours glows with the familiar starlight that fills your night sky. But this is only one possibility. Another idea suggests that the multiverse rises not from bubbles, but from parallel realities, multiple versions of existence unfolding side by side. In this view, every choice, every quantum event, every branching possibility creates another universe where events unfold differently. There might be a version of you who chose another path, another dream, another moment, not to overwhelm, but to wonder. How many versions of reality quietly unfold alongside our own? Picture a vast library, stretching into infinity, each book containing the story of one universe. Some books resemble ours closely, others are wildly different. Some hold galaxies shaped by physical laws we could barely imagine. Others have stars that burn in colors unknown to any eye. And somewhere in that endless library, your world is just one story among countless others, no less special, no less meaningful. The multiverse softens the idea of limits. It whispers that the cosmos may be far larger, far more layered, far more intricate than the piece of it we can observe. Instead of a single universe with fixed laws, reality might be a tapestry, woven of countless threads, each one shimmering with its own pattern. There are theories shaped by higher dimensions too, hidden spaces curled up within the fabric of our universe. According to string theory, reality might have more than the 3 dimensions we move through, and the 1 dimension we experience as time. There could be extra dimensions folded into tiny spaces, invisible to us but essential to the structure of everything. And in these higher dimensions, entire universes could exist, layered like pages in a book, too thin to separate with human fingers. Imagine walking through a room, but never noticing the worlds drifting just a hair's breadth away. Worlds that overlap yours without ever touching it, like shadows slipping past each other. Our universe might be a membrane, a brain, floating in a higher dimensional space, with other membranes drifting nearby. When 2 such brains collide, they could spark new universes. Perhaps our own began in such a cosmic meeting, a gentle brushing of dimensions that ignited a new universe into being. If you let your thoughts drift deeper into this idea, a soft realization appears. The universe we observe may be only a fraction of all that exists. Yet what is beautiful about the multiverse is not whether it is true or false. It is the possibility it represents. It invites us to imagine reality not as a rigid structure, but as something fluid, diverse, endlessly creative. It makes the cosmos feel more alive, more abundant, more filled with quiet surprises waiting to be discovered. Even if we can never reach these other universes, their existence would change how we see our own. The delicate balance of physical laws, the strength of gravity, the brightness of stars, the chemistry of life, might be unique to our universe. In another universe, stars could be smaller, or larger, or non-existent. Galaxies might form faster or never form at all. Atoms might behave differently. Time might flow in unfamiliar ways. And yet, here we are, in a universe that allows galaxies to spin, planets to form, oceans to shimmer, consciousness to breathe. A universe that unfolds in gentle rhythms, with laws tuned so precisely that atoms bond, stars shine, and life dreams under soft starlight. If infinite universes exist, then ours is one glowing note in a cosmic symphony, quiet, precise, and full of wonder. The multiverse also invites a gentle reflection on choice and possibility. In some interpretations, every quantum event creates branches, a splitting of paths where different outcomes unfold. Somewhere, a version of reality could hold the opposite of every decision, the unexplored paths that drift quietly in the background of our lives. And whether or not these parallel lives truly exist, the idea itself reminds us of the vastness of possibility within every moment. Perhaps the most comforting aspect of multiverse theories is this: they remind us that the universe is not small, and neither are we. Even within one lifetime, within one world, you are part of something infinitely larger, woven into a reality that may be only one layer of a cosmic tapestry without end. And as you float through these thoughts, you may feel the boundaries of your imagination expanding softly, much like the universe itself, reaching outward into quiet possibilities beyond sight, beyond time, beyond the edges of everything you know. Somewhere, unseen but not impossible, countless universes drift gently through the infinite, each carrying its own story, its own light, its own mysteries. And among them, our universe glows calmly, one of many, yet uniquely beautiful. Cosmic strings, hypothetical remnants of the early universe. There are ideas in cosmology so delicate, so strange that they feel less like scientific theories and more like whispers from the edge of creation. One of these whispers is the idea of cosmic strings, infinitesimally thin, unimaginably long strands of energy left over from the earliest moments of the universe. They have never been seen, never been touched, never been confirmed. And yet their possibility lingers in the quiet corners of theoretical physics, like a memory the universe has not quite forgotten. To understand cosmic strings, imagine the universe as it was just after the Big Bang, hot, dense, rapidly expanding, and shifting through phase transitions the way cooling water turns to ice. In those early transitions, the fabric of space-time might have crumpled in places, leaving behind narrow, frozen defects, thin cracks where the universe didn't settle perfectly. Those cracks, if they exist, are cosmic strings, but these are not strings made of matter. They are strings made of pure energy, infinitely thin, much thinner than an atom, incredibly dense. 1 kilometer of a cosmic string could outweigh a mountain, and astonishingly long, stretching for light years, perhaps looping around the entire universe. If you were drifting through silent cosmic space and passed near one, you might not see anything at all. There is no light, no glow, no surface to touch. But you would feel a warping, a bending of space itself, as if the universe were gently pinched along an invisible seam. Cosmic strings would not pull like gravity. They would slice through space-time, creating distinctive distortions that ripple outward quietly. Imagine a knife so perfect it leaves no visible mark, but changes everything it passes through. That is a cosmic string. If 2 of these strings were ever to cross, the moment of contact would be subtle but profound. They might merge, or rebound, or even loop into smaller rings that oscillate like cosmic guitar strings. But instead of sound, these oscillations would send out gravitational waves. Tiny ripples in space-time drifting through the universe like gentle echoes from the dawn of everything. Scientists search for these ripples today, hoping that somewhere in the quiet hum of gravitational wave detectors, a cosmic string has brushed against reality just long enough to leave a signature. The idea of cosmic strings emerged from attempts to understand how the universe took on its large-scale shape. If strings existed in the early cosmos, they might have acted as gravitational anchors, drawing matter around them, seeding the growth of galaxies, like threads woven through a vast tapestry, guiding where the patterns form. Picture the early universe as a soft, warm sheet being cooled. As it settles, tiny wrinkles form, slight imperfections frozen into its surface. Those imperfections could be cosmic strings, stretching across space like the faintest lines of tension. Even today, if a cosmic string passed between you and a distant galaxy, its gravity would create a strange effect, a double image. The galaxy would appear twice, side by side, as light bent around the invisible seam. Astronomers look for such clues, pairs of galaxies that should not be paired, light that seems to split for no apparent reason. Each possibility is a quiet question from the universe, asking us to look closer. But cosmic strings, if they exist, are rare. The universe is old. These strings might have decayed, snapped, or shrunk into loops that radiated away their energy long ago, and yet the idea persists because it carries a deep truth, that the universe we see today may still hold the fingerprints of its earliest moments. Even if we never find cosmic strings, the concept reminds us of something beautiful. The universe is not smooth. It is textured, layered. It holds memories in its fabric, memories of transitions and creations, of rapid expansion and cooling, of the first fractions of a second when everything we know was set into motion. Cosmic strings are a theoretical bridge to that time, an idea that lets us reach into the past and gently trace the outlines of creation itself. Imagine floating beyond galaxies, past clusters into the great cosmic voids where nothing stirs. In that deep quiet, you pass through a region of space that looks perfectly ordinary. No light, no heat, no sound. And yet, space feels subtly stretched, subtly different, as if reality itself is holding a single long breath. That is how a cosmic string would exist, present, invisible, powerful in its silence. The thought of such objects drifting unseen through the cosmos has a soothing charm. It reminds us that not all wonders are loud or bright. Some are silent, some are theoretical, some are possibilities waiting patiently for discovery. Cosmic strings may be imaginary, they may be real, they may lie beyond the reach of our instruments forever. But in imagining them, we stretch our minds into shapes as vast as the universe itself. And as you drift through the calm possibilities of these ancient, hypothetical remnants, a gentle truth settles in. The universe we know is only one layer of a story still unfolding, full of secrets woven into its very fabric, quiet threads of energy stretching across eternity, waiting for the moment when we finally learn how to see them. Neutron stars and pulsars, the densest objects after black holes. When a massive star reaches the final moment of its life, its core collapses inwards with unimaginable force, squeezing matter into a form so dense, so compact, that the atoms themselves can no longer remain as they were. Electrons and protons merge into neutrons, space buckles, gravity deepens, and what's left behind is one of the most extraordinary objects in the universe, a neutron star. A star reduced to a sphere no larger than a city, yet heavier than an entire mountain range. Imagine something the size of Lahore, but with the mass of the sun. Imagine a teaspoon of its material weighing more than Mount Everest. Imagine a surface so dense that light bends over it, curving softly around its shape. This is a neutron star, an object born from collapse, surviving where nearly nothing else could. If you were to drift through the universe and come upon one, you might not even notice it at first. There is no swirling brilliance like a supernova, no glowing shell of gas. It would appear as a small, dim sphere suspended in silence. But if you looked closer, you'd feel the immense gravity weaving the space around it, like a gentle hand pulling everything inward, reshaping the paths of light itself. The surface of a neutron star is smoother than steel and harder than diamond. Below that surface lies a crust of tightly packed neutrons, forming layers that grow denser the deeper you go. At the core, physics becomes almost imaginary, matter compressed into forms we can barely describe, where neutrons may melt into a sea of quarks, or even stranger particles still unconfirmed by science. It is a place where the rules of reality bend, soften, and blur. Some neutron stars spin, and they spin fast. Very fast. When the original star collapses, all its rotation is squeezed into a tiny space, making the remnant whirl like a cosmic figure skater pulling in their arms. These spinning neutron stars are called pulsars, and they are among the most hypnotic objects in the sky. A pulsar rotates with such precision that each spin sends out beams of radiation sweeping across space like the beam of a cosmic lighthouse. If Earth lies in the path of those beams, we detect pulses of radio waves, steady, rhythmic, ticking like a clock built not by human hands, but by the universe itself. Some pulsars spin dozens of times per second. Some spin hundreds of times per second. There are pulsars that complete a full rotation in the time it takes you to blink. And yet, despite their unimaginable speed, they remain stable, pulsing steadily through cosmic silence, their timing so perfect that astronomers use them as natural clocks to measure gravitational waves and probe the deep structure of space-time. Imagine floating above a pulsar, watching its beams sweep around like soft arcs of invisible light. Each pulse would feel like a heartbeat from a distant world, steady and calming. The universe rarely offers such regularity, but pulsars do. Their precision is soothing, hypnotic, like the ticking of a watch in a quiet room. Neutron stars also have magnetic fields far stronger than anything found anywhere else in the cosmos. These fields twist and ripple into space, shaping the environment around them. A special kind of neutron star called a magnetar holds magnetic fields so intense that they could erase information on a credit card from halfway across the Earth. Yet even magnetars sit in perfect silence, glowing faintly, rotating slowly, holding their energy like a coiled storm waiting beneath a calm surface. Despite their quietness, neutron stars interact with their surroundings in beautiful ways. When a neutron star has a companion, another star orbiting it, the neutron star can pull material from its partner, creating streams of glowing gas spiraling inward. As this material falls, it heats up and emits X-rays, forming a dance of light around an object no larger than a city. These systems shine brightly across the cosmos, sending delicate flickers through the void. But perhaps the most awe-inspiring moment happens when two neutron stars spiral toward each other. Their gravitational pull tightens, their orbits shrink, and they begin to merge in a quiet, slow-motion collision. The energy released is enormous. Gravitational waves ripple outward, shaking space-time itself. Gold, platinum, and heavy elements are forged in the aftermath, scattered into the universe to someday become planets, jewelry, or the atoms in your body. When scientists detected gravitational waves from a neutron star merger for the first time in 2017, they were listening to the sound of creation, literally hearing the universe speak through ripples in space-time. It was a soft, rising tone, fading gently, like the sigh of two stars collapsing into each other after billions of years. Neutron stars remind us that even in death, stars continue shaping the cosmos. They are relics, memories, monuments to stellar lives long ended. Yet they shine, not with light, but with precision, gravity, and silence. What makes neutron stars so calming to think about is not just their exotic nature, but their patience. They rotate for millions of years. Their pulses echo through galaxies. Their gravity holds steady through eras longer than human imagination. They feel like the universe's anchors, tiny, dense reminders that even after chaos and collapse, structure remains. Order emerges, stillness appears. And somewhere in the quiet dark between galaxies, a neutron star is spinning right now, steadily, rhythmically, endlessly, unseen but ever present. A lighthouse in the void. As your thoughts drift with the slow rhythm of these cosmic objects, you may feel a deep, gentle reminder. Even the universe's most extreme transformations can lead to calm. Even collapse can create stability. Even endings can birth something steady, something peaceful, something profoundly beautiful. Neutron stars are proof that after the brightest explosions come the quietest wonders, and their pulses continue across the darkness, whispering softly into eternity. Quasars, the brightest beacons in the cosmos. In the quiet vastness of the universe, there exist objects so bright, so distant, and so powerful that they shine across billions of light years, reaching us long after the galaxies around them have shifted and evolved. These luminous giants are called quasars, the brilliant hearts of young galaxies, glowing with a radiance that outshines entire clusters of stars. And yet their incredible brightness comes from something profoundly dark. At the center of almost every quasar lies a supermassive black hole, devouring matter with a hunger so immense that space itself bends around it. But contrary to what we might imagine, a black hole is not bright. It is perfectly dark. The light of a quasar comes instead from the swirling disk of matter spiraling toward the black hole. The accretion disk, heated to extraordinary temperatures as it falls inward. Imagine a whirlpool of gas and dust collapsing toward a silent center, spinning faster and heating hotter until it glows with the brilliance of billions of suns. That is a quasar, a luminous halo wrapped around a darkness so deep that nothing can escape. When quasars first appeared in early astronomical surveys, they were tiny points of light, quasi-stellar objects, too bright to be stars, too compact to be galaxies. Their redshifts revealed that they were incredibly far away, meaning their true brightness was beyond anything we had imagined. The universe, it turned out, had been flooded with these brilliant beacons in its youth. Quasars lived in an era when galaxies were young and full of gas, fuel waiting to be consumed. As the supermassive black hole at a galaxy's core fed on this abundant material, it ignited a quasar, illuminating the cosmos in every direction. Jets of energy erupted from the poles of the black hole, shooting across space like silent cosmic lighthouses, their beams traveling millions of light years. These jets are made of particles accelerated to near light speed, twisted and guided by magnetic fields in ways both beautiful and strange. If you could watch from a distance, you'd see long blue streams stretching like threads of light in the dark, a reminder that even the most extreme forces can create elegance. Yet despite all their brilliance, quasars are incredibly calm in their rhythm. Their flickers happen over years, their brightening and dimming gentle, like breaths taken by galaxies still finding their shape. There is nothing chaotic about a quasar's glow. It is steady, patient, as if the universe itself is holding a lantern against the darkness. What makes quasars so soothing to imagine is their perfect balance of extremes. A dark heart surrounded by radiant light, a destructive force that becomes the source of cosmic illumination, a silent black hole generating the brightest glow in all existence. As material spirals into the accretion disk, it forms elegant patterns, swirls and streams, heating into white-hot plasma. The inner regions glow brightest, swirling at incredible speeds, their motion time-dilated by gravity. Light itself struggles to escape, but somehow, through magnetic fields and rotational momentum, jets emerge at the poles, carrying energy outward with astonishing grace. And so a quasar shines, brighter than any star, brighter than any galaxy, a cosmic beacon reaching across the expanding universe. If you were drifting near one, the view would be surreal. A brilliant disk spinning around a dark hole, arcs of glowing matter curving inward, and long jets rising like towers into the void. It would feel like standing near a cosmic waterfall, beautiful, powerful, yet silent in the vacuum of space. Quasars also serve as cosmic time machines. Because they are so bright, we can see them from incredibly far away. The light we observe left them billions of years ago, when the universe was young. Every quasar is a message from the distant past, a glimpse into the universe's childhood. When you look at a quasar, you are looking back to a time when galaxies were forming, stars were being born in great waves, and the cosmic web was still tightening into place. Some quasars flicker softly over time, dimming and brightening with the ebb and flow of matter in their accretion disks. Others remain constant, like a star that never fades. Their rhythms are quiet, natural, shaped by gravity's patient pull. Eventually, quasars grow quiet. As galaxies age, their reservoirs of gas thin out. The supermassive black hole has less to feed on. The accretion disk cools. The jets fade. The brilliant beacon settles into a slumber, leaving behind an ordinary galaxy with a silent black hole at its center. Our own Milky Way once may have shone as a quasar, billions of years ago when it was young and full of gas. Now its central black hole rests in a calm state, feeding only lightly, glowing only faintly. Galaxies, like stars, have phases, times of brilliance, times of quiet, and quasars mark the most luminous of those phases. As you drift through the thought of quasars lighting the early universe, a gentle realization surfaces. Even the brightest moments in cosmic history are fleeting. Even the most powerful engines quiet down. And even the largest structures in existence have soft, peaceful endings. The universe is full of lights that rise, shine, and fade. Quasars are the brightest of these lights, but their glow is a chapter, not the whole story. Their brilliance illuminates the darkness, but their silence afterward is equally profound. In the gentle rhythm of cosmic evolution, quasars remind us that beauty does not require permanence. It exists in moments, in flashes that light the void, in bursts that echo across time, in the memory of radiance long after the light itself has faded. Somewhere, billions of light years away, a quasar is shining right now. Its glow has been traveling toward you for longer than Earth has existed. Long after you exhale your next breath, long after this century has passed, its light will still be crossing space, softly, calmly, steadily. A cosmic lantern drifting through eternity, whispering the story of a universe young and brilliant. Dark flow, the strange motion of galaxy clusters. In the stillness of the cosmic ocean, where galaxies drift like glowing islands in a dark sea, there exists a mystery so subtle and so vast that it stretches beyond the reach of our most powerful telescopes. It is called dark flow, a quiet, steady motion that seems to pull entire clusters of galaxies in one direction, as though some hidden current beneath the universe is guiding them. Imagine this: galaxies, each containing hundreds of billions of stars, drifting not randomly, not gently expanding apart as expected, but moving together, as if responding to a distant whisper. Astronomers discovered this strange motion while studying the cosmic microwave background, the faint afterglow of the Big Bang. Against that ancient backdrop, galaxy clusters should look evenly scattered, expanding uniformly in all directions. But they don't. Some clusters show a subtle movement, a drift toward a region of sky we cannot see. It isn't the expansion of the universe. It isn't gravity from anything we know. It isn't dark matter. It is something else. And because we don't know what it is, we call it simply the dark flow. Picture yourself floating outside the Milky Way, watching galaxy clusters drift across the cosmic web like glowing lanterns. They aren't falling toward another galaxy cluster, or toward a supercluster, or even toward a void. They're moving toward something beyond the observable universe, a region we cannot access, cannot measure, cannot even imagine clearly. Whatever lies beyond our cosmic horizon may be pulling them, or pushing them, or calling them in a way physics has not yet explained. When the discovery was first announced, astronomers felt a quiet shiver of wonder. It hinted that our universe might not be a self-contained bubble. It suggested that something outside the visible cosmos has a gravitational influence strong enough to tug at galaxy clusters billions of light years away. The idea is mind-bending, it is soothing, and it is a little haunting, because what kind of structure, what kind of mass, what kind of hidden realm could pull galaxies across such impossible distances? As you picture this silent drift, imagine the galaxies themselves, massive spirals, glowing ellipticals, slender lenticulars, gliding through space like luminescent ships in a dark, boundless ocean. Their motion is not violent. It is not chaotic. It is slow, gentle, persistent, like a breeze that never stops blowing. The flow is so faint we only detect it through tiny temperature patterns in the cosmic microwave background. These patterns are like soft ripples on the surface of a still lake, small, delicate hints of something vast beneath. Some theories suggest that the dark flow is caused by a previous universe, a cosmic neighbor that existed before or beside our own. Others imagine a multiverse landscape, where other universes press against ours like bubbles in a cosmic foam. A few imagine immense structures beyond our sight, perhaps clusters or superclusters so large they make everything we see feel miniature. And then there is the most poetic possibility that the universe is not uniform at all, that the regions beyond our cosmic horizon are wildly different. shaped by conditions we cannot measure but whose gravity we still feel. As you let that idea drift across your thoughts, imagine the boundary of the observable universe. Not a wall, not an edge, but a soft fading of visibility, like mist blurring the farthest mountains. Everything beyond that mist is hidden, but not necessarily absent. Something beyond the mist might be whispering to the galaxies, calling them, guiding them. The dark flow is not fast. It is not loud. It is not chaotic. It is a gentle cosmic tide, a slow-motion current that has been flowing for billions of years. Long before Earth formed, long before the Milky Way took shape, galaxy clusters were already drifting toward that mysterious region of sky, and they will continue drifting long after our own galaxy's stars fade. What makes dark flow so soothing to imagine is its quiet certainty. It doesn't rush, it doesn't strain, it just continues, softly, steadily, like the calm pull of a river guiding fallen leaves downstream. Sometimes astronomers try to map it to find the exact coordinates of the flow's destination. But the truth is, we cannot see far enough. The universe is expanding too quickly. The horizon of visibility always moves away from us, like a shoreline forever out of reach. And so the mystery remains. Dark flow is a reminder that the universe is not fully mapped, not fully known, not fully illuminated. There are regions from which no light will ever reach us, regions whose influence we still feel in the subtle choreography of galaxy clusters. In that quiet motion lies the echo of something ancient, perhaps a remnant of cosmic inflation, perhaps a signature of a universe beyond ours. Let the thought drift through you. Entire clusters of galaxies, billions of stars, billions of planets, moving gently toward a place we can never see. It makes our own world feel wonderfully small, yet deeply connected to the larger cosmos. We are part of a universe that flows, shifts, breathes, and responds to forces older than time. As you breathe softly, picture those distant clusters continuing their endless motion. They don't hurry, they don't resist. They simply drift, guided by a force that remains unseen, yet beautifully present. Somewhere out there, beyond our cosmic horizon, something is pulling. Something immense, something silent, something ancient. And though we may never discover what it is, the mystery itself becomes a kind of comfort, a gentle reminder that the universe still holds secrets, and that not knowing everything is part of its quiet beauty. In the end, dark flow is more than a puzzle. It is a cosmic lullaby, a soft tug at the edge of the universe, a whisper saying that creation is deeper, broader, and more mysterious than we can ever measure, a flow that never stops, a motion that never rests, a reminder that even in the vastest stillness, the universe is always drifting towards something more. Time dilation, how gravity and speed bend. Time. Time is something we feel but cannot hold. It moves through us and around us, shaping every moment of our lives. But out in the universe, time isn't the steady, familiar rhythm we experience on Earth. It bends, it stretches, it slows. It flows differently depending on where you stand, how fast you move, and how deeply gravity pulls at you. This quiet bending of time is called time dilation, and it is one of the most gentle yet mind-shifting truths in all of physics. Imagine holding a clock in your hand. Now imagine setting that clock near the surface of a massive object, a neutron star, a black hole, or even just a planet more massive than Earth. The clock will begin ticking more slowly, not because it is broken, not because something interfered with it, but because time itself has slowed down around it. Gravity pulls not only on matter, but on time. And the stronger the gravity, the slower time flows. If you were to stand at the foot of a massive mountain while a friend climbed to the top with an identical clock, their clock would run slightly faster than yours. The difference would be tiny, almost unnoticeable, but real. If you lived your entire life deep within a gravitational well while they lived higher above, you would age a little more slowly. Just by standing in different places, you and your friend would drift into different futures. Now imagine drifting near a black hole, silent, immense, its gravity curving space like a deep well in the fabric of the universe. Time around you would slow to a gentle crawl. Minutes for you might be hours or years for someone far away. Your heartbeat would move at its normal pace, but the universe beyond the black hole would whirl forward like a fast-moving river. Time dilation isn't strange or violent. It's soft, subtle, a gentle shifting in the flow of reality. Speed also bends time. The faster you move, the slower time flows for you. A person traveling on a spacecraft near the speed of light would return home to find that everyone else has aged more than they have. Their journey might feel like months, but for the world they left behind, decades could have passed. This isn't a trick. It isn't science fiction. It's woven into the laws of space-time. Even your GPS uses time dilation. Satellites orbiting high above Earth move fast and sit farther from gravity's pull. Their clocks run slightly quicker than clocks on the ground. If we didn't account for that difference, your phone would place you miles from where you really are. Every time you see your location on a map, you are using Einstein's equations quietly, effortlessly, correcting the flow of time. When you imagine the universe as a calm ocean, time dilation becomes the gentle waves that rise and fall as the terrain beneath them shifts. Deep valleys slow the water. High ridges let it flow freely. And motion stirs the surface, shaping the rhythm even further. Time is not constant. It is elastic. It drapes itself around gravity. It stretches across speed. In the calm darkness of space, two clocks placed just a short distance apart can drift out of sync simply because gravity touches them differently. The universe breathes through time. Every massive object, every star, every planet, every black hole is a weight placed on that breath, shaping its pace. If you drifted close to a black hole, you might see the stars around you shimmer and fast forward. Clouds of gas would swirl rapidly. Galaxies would rotate like slow whirlpools, sped up 1,000 times. Your perception would remain peaceful, unchanged. You would feel as though only moments had passed, but the universe would run ahead without you. It's almost poetic to think you could step into a deeper gravity and slip into the future, not by imagination, but by the quiet rules of physics. Somewhere, far across space, binary stars spiral around each other, their immense masses slowing the clock between them. Neutron stars pull time tight, like stretched fabric. Magnetars bend it into deep curves. Black holes twist time until it becomes almost still. The universe never stops bending and stretching its own rhythm. Time flows differently in distant galaxies, near cosmic giants, inside swirling nebulae, and even across the rooms of your own house. You don't feel the difference, but the universe does. As you breathe gently, imagine yourself floating in a region of space where gravity is soft and light. Time flows quickly there, like a breeze through tall grass. Now drift downward toward a massive star. Feel the flow slow, like sinking into warm, still water. Nothing feels dramatic. Nothing feels strange. But time itself changes pace, cradling you in its shifting rhythm. And somewhere inside this cosmic lullaby, a thought settles softly. Time dilation isn't a distortion. It's a gift. A quiet, graceful reminder that the universe is not rigid. It is alive with motion and curvature, shaped by mass and speed, sculpted by the invisible breath of space-time. Time dilation tells us that the universe is not a single synchronized clock. It is a symphony of many clocks, each ticking gently at its own tempo, each shaped by where it rests. and how fast it travels, and how deeply gravity touches it. You, right now, are living your own tempo, your own quiet rhythm in the cosmic symphony. Somewhere far away, another being, on a world with heavier gravity or lighter mass, feels time differently, though neither of you would know it. And yet, across those differences, the universe connects everything with the same gentle truth. Time is flexible. Time is alive. Time is the quiet pulse of the cosmos. As you let this thought settle, imagine time stretching softly before you, a long golden ribbon winding through stars and galaxies, bending around black holes, flowing through nebula, shimmering across cosmic dust. And you are part of that ribbon, a moment within an endless, drifting tapestry, a heartbeat inside the rhythm of space-time, cosmic evolution, from first atoms to modern structure. In the beginning, there was no shape, no structure, no stars, no galaxies, only a glowing sea of particles suspended in the newborn universe. Everything was hot, bright, dense, and impossibly simple. Yet within that simplicity lay the quiet potential for everything that would one day exist: planets, stars, oceans, mountains, and life itself. Cosmic evolution is the story of how this simplicity unfolded, how the universe softened, cooled, and slowly organized itself into the intricate cosmic web we see today. And like all great stories, it begins with a breath. After the Big Bang, the universe expanded and cooled until the first atoms, hydrogen and helium, were born. Imagine those atoms drifting like tiny lanterns in a vast, dark ocean. They carried within them the seeds of future stars, but in those early moments, the universe was silent, calm, almost featureless. Slowly, gravity began to gather these atoms, pulling them together into delicate clouds. At first, the clouds were faint, almost invisible, but over millions of years, they grew dense, swirling, tightening, like cosmic mist collapsing into beautiful spirals. In these clouds, pressure rose, heat built, and at the center of these young knots of matter, the first stars ignited. The universe went from darkness to light. These first stars were enormous, far larger than the stars we see today. They burned hot, lived briefly, and died in spectacular explosions. Their brilliant deaths scattered new elements into space: carbon, oxygen, iron, the ingredients of worlds. Cosmic evolution is a cycle of creation and quiet return. Hydrogen becomes a star becomes an explosion becomes dust, and dust becomes new stars, new planets, new possibilities. Every atom of your body, every breath you take, was part of this cycle. Cosmic evolution is not just the story of the universe, it is your story. As these early stars died, their remnants collected into great swirling galaxies, vast collections of stars orbiting in slow, graceful spirals. Galaxies collided, merged, spun together like dancers in a cosmic ballet that unfolded over billions of years. But even these large structures were not the end of the universe's creativity. Clusters formed, groups of galaxies bound together by invisible threads of dark matter. These clusters became part of something even larger, the cosmic web, a tapestry of filaments and voids, dense knots and empty expanses, stretching across the universe like delicate lace. If you could step back far enough, light years upon light years, you would see the universe as a glowing network, bright where matter gathers, dark where it drifts apart. Cosmic evolution sculpted this web softly, patiently, without haste. And through all of this, the universe continued to cool. Where once it glowed like a furnace, now it shimmered with stars. Where once it roared with creation, now it whispered with the sound of galaxies drifting in the dark. Time smoothed the chaos. Gravity shaped the journey, and everything that would one day live, breathe, or feel found its place in the unfolding design. As you drift deeper into this story, imagine the slow passage of billions of years, not as something overwhelming, but as a gentle tide that lifts and lowers the universe. Entire galaxies rise like waves, then merge, dissolve, and reform. Stars pulse, shine, and fade. Dust gathers, warms, and gives birth again. The universe is not static. It is alive with motion, constantly evolving, constantly reshaping itself into new forms. Somewhere, clouds of gas are collapsing into stars at this very moment. Somewhere else, galaxies are colliding in slow, silent arcs. And far away, in regions untouched by starlight, the next generation of cosmic structures is just beginning to take shape. One of the most soothing truths of cosmic evolution is its patience. Nothing is rushed, nothing is hurried. Even the most dramatic events, supernova explosions, galaxy mergers, black hole formations, unfold over timescales so long they feel like gentle whispers. And woven into this calm motion is an astonishing fact. Cosmic evolution always builds on what came before. The first atoms led to the first stars. The first stars led to the first heavy elements. Those elements formed planets, oceans, atmospheres, and eventually, life. Life looked up at the stars and began to wonder where it came from. In that wondering, the universe finally became aware of itself. Cosmic evolution is the universe remembering its own beginning. Stars study their ancestors through telescopes. Galaxies measure the echoes of their own formation. And on a small blue world, beings made of stardust whisper questions into the night, seeking answers written in light billions of years old. Sometimes, when astronomers map the cosmic web or trace the chemistry of ancient starlight, they find patterns shaped by events from the earliest moments after the Big Bang. Ripple-like signatures frozen in place reveal the rhythm of a universe cooling and expanding, like the lingering hum after a bell has been struck. These faint traces remind us that nothing in the universe is truly lost, not the light of ancient stars, not the dust of long-dead suns, not the whispers of the first atoms drifting through the early cosmos. Every step of evolution leaves a footprint somewhere, etched into space, stored in stardust, remembered in the glow of galaxies. As you let that thought settle, imagine the night sky as a vast archive where every point of light tells a chapter of the same gentle story. The universe doesn't rush toward an ending. It simply moves from one state of beauty to another, and you are part of that movement. Your atoms once drifted through ancient nebulae. Your carbon once burned inside a star. Your existence is a page in the universe's long, peaceful book. Cosmic evolution is still happening now. It is happening around you. It is happening within you. A steady unfolding, a soft, timeless becoming, a breathing universe gently shaping itself into new forms. And somewhere in that endless continuity, the cosmos invites you to rest, to drift with its slow rhythm, to feel the quiet truth that everything changes, but everything remains connected. The cosmic web, filaments, voids, and the universe's large-scale shape. If you could drift far beyond the Milky Way, past its spiraling arms and glowing dust lanes, if you could rise even farther, beyond its halo of stars, beyond the quiet gravitational embrace of our local group, beyond the clusters and superclusters that bind galaxies together, eventually the universe would begin to reveal its true shape, not a random scattering of galaxies, not a uniform sea of stars, but a delicate pattern, vast, intricate, and breathtaking in its scale. This is the cosmic web, the universe's grand architecture, a network of filaments, knots, and voids stretching across billions of light years, forming the largest structure ever known. It looks almost alive. Thread-like filaments weave across the darkness like glowing veins. Clusters of galaxies gather at intersections like bright nodes, and between them lie enormous empty regions, voids, quiet expanses where almost nothing resides. From far enough away, the cosmic web resembles the neural pathways of a colossal mind, or the branching of a tree, or the lacework patterns left by frost on a window. Shapes repeated across scales so immense they defy intuition, and yet everything in the night sky, from the smallest dwarf galaxy to the brightest quasar, lives somewhere within this web. To understand how the cosmic web formed, we need to drift back in time, far, far back, to a moment when the universe was still young. After the Big Bang, the universe was nearly uniform, almost smooth, but not perfectly. Tiny fluctuations in density, little ripples, were scattered across the cosmos. These gentle bumps in the early universe were seeds of all future structure. Where the density was slightly higher, gravity tugged more strongly. And over millions of years, matter flowed inward, gathering, clumping, growing denser still. A quiet cascade, like raindrops flowing into streams, streams collecting into rivers, rivers merging into oceans. The universe, too, found its rivers, long filaments of matter stretching across the dark. These filaments thickened over time, threaded with dark matter, shaped by its invisible pull. Gas followed. Stars formed. Galaxies emerged. Superclusters assembled at the densest intersections, massive knots where countless galaxies clustered together. And between these filaments, where matter had flowed away, the voids expanded, great silent pockets spanning hundreds of millions of light years. Imagine floating inside one of those voids. The nearest galaxy might be unimaginably far away. Space would feel empty, still, serene. A cosmic desert where even starlight seems shy. Yet the voids are just as important as the filaments. Without emptiness, structure cannot grow. Without silence, music cannot form. The universe needs both. The cosmic web is not static. It evolves slowly, gracefully, over billions of years. Filaments stretch and thin as the universe expands. Galaxies glide along these filaments like boats drifting down interstellar rivers. Clusters merge, forming even larger structures, vast cities of galaxies connected by glowing bridges of matter. Dark matter forms the skeleton of this web. Ordinary matter, the kind that makes up stars and planets, fills in the details. And while the cosmic web spans unimaginable distances, it is also astonishingly delicate, like a spider's web floating through space, shaped by forces subtle and ancient. As astronomers mapped galaxies across the sky, they began to see this structure emerge. At first, it was unexpected, too organized, too patterned for what they imagined the universe might look like. But the deeper they looked, the clearer the image became. The universe is not random, it is woven. Every galaxy cluster sits in its place. Every void balances another. Every filament stretches from one bright intersection to the next in a quiet harmony of gravitational dance. And somewhere in this cosmic web, the Milky Way occupies a single shimmering thread, not too dense, not too empty, drifting gently toward a massive structure known as the Great Attractor, carried along by flows older than Earth itself. The beauty of the cosmic web lies not only in its structure, but in what it represents, how the universe grew from simplicity into complexity. From a nearly uniform sea of particles to a vast network of luminous islands, from soft ripples in the early cosmos to the grand woven tapestry visible today, there is something deeply soothing in imagining this slow evolution, this gentle knitting of structure across time. No rush, no forceful shaping, just gravity, patience, and the quiet unfolding of creation. As you picture the cosmic web stretching out in every direction, imagine drifting along one of its filaments. Below you, stars cluster like fireflies. Far ahead, a galaxy cluster glows like a lantern suspended in dark water. Behind you, the filament narrows, threading its way toward distant regions you will never reach. And all around you, the faint hum of cosmic expansion keeps time, soft, steady, eternal. Sometimes we forget that the night sky we see is only a local view, a small neighborhood within an unfathomably large structure. Each star twinkling above you is just a grain of dust on a single galactic branch. Each galaxy photographed by telescopes is a small knot on a single cosmic thread, yet each point of light, each cluster, each filament plays a part in the grand design. The cosmic web whispers that nothing exists alone. Galaxies are not solitary wanderers. They are connected by invisible gravitational ties, born from ancient ripples and shaped by dark matter's silent hand. As the universe continues to expand, the web will stretch further, filaments will thin, voids will widen, galaxies will drift quietly along the threads until one day, far in the future, the web becomes so faint that only memory, written in starlight, will remain. But for now, the universe is still glowing with structure, still weaving new threads, still whispering its story across the darkness. And as you rest here, imagining these filaments winding through the cosmos, there is a gentle comfort in knowing that you, too, are part of this grand design, made of atoms forged in stars that once drifted along these ancient threads, a tiny spark within the cosmic web, a moment of awareness in the universe's endless unfolding, a soft light glowing quietly in the vast dark. Gravitational waves, ripples in space-time. Imagine the universe as a vast, silent ocean, dark, serene, stretching farther than sight, farther than imagination. Now imagine something disturbing that stillness, a ripple, a tremor, a gentle wave spreading outward through the deep fabric of space-time itself. This is a gravitational wave, a whisper from distant cosmic events, traveling across the universe not as light, not as sound, but as the stretching and squeezing of reality. Long before we detected these waves, Einstein predicted them, a quiet idea tucked within his equations of general relativity. He imagined that when massive objects moved violently enough, they would send ripples through space-time the way a stone sends ripples across a pond. But what kind of stone could disturb the cosmic ocean? What kind of event could send waves across billions of light years? The answer is both awe-inspiring and peaceful, the dance of massive celestial bodies. Two black holes spiraling together, two neutron stars brushing ever closer, even the collapse of a dying star. These motion, unfolding in slow cosmic rhythms over millions of years, create tiny pulses in space-time that travel outward forever. For decades, we thought these waves were too faint to ever detect. They were small, so small that by the time they reached Earth, they would stretch and compress our planet by less than the width of an atom, quiet beyond quiet, still beyond stillness. And yet, in 2015, humanity heard one. Inside, enormous detectors built with almost impossible precision, lasers traced delicate paths. Mirrors waited, suspended in vacuum. The instruments were so sensitive that even a passing truck could interrupt them. But one calm day, the laser beams trembled just slightly, an almost imperceptible flutter. That flutter was a message, a ripple in space-time, a greeting from two black holes that had collided more than 1 billion years ago. The wave that reached us was faint, infinitely gentle, yet it carried the story of a cataclysm long faded. A story older than mountains, oceans, or life. When scientists translated the signal into sound, it made a short, rising note, a chirp, a cosmic heartbeat, a moment of creation echoing through silence. Gravitational waves don't just tell us that something happened, they let us feel the universe. Unlike light, which can be blocked by dust, or radio waves, which can scatter, gravitational waves pass through everything. They carry pure information. They come to us unaltered, whispering secrets of places light could never reach. Imagine two neutron stars spiraling toward each other. They orbit faster, closer, tighter, like dancers stepping in tighter circles. The fabric of space-time around them ripples outward with each revolution. At the moment they collide, a burst of gravitational waves spreads through the universe like the soft ringing of a struck bell. Now imagine drifting in deep space as one of those waves passes over you. You wouldn't feel anything. There's no motion, no jolt, no sound, but in that moment, your atoms are stretched and compressed in perfect synchrony with the wave's passing rhythm. The universe reached out and touched you, ever so gently. As you drift further into this thought, imagine the entire cosmos humming quietly. Every massive movement, every star collapse, every merger, every cosmic dance produces its own tiny ripple. The universe is never silent. It sings through gravity. Some waves roll slowly, drawn from massive black hole mergers deep in space. Others come faster, from smaller objects spinning rapidly, like neutron stars emitting steady pulses. Some waves are chaotic, some are rhythmic. All of them travel endlessly, crossing galaxies, passing through stars, through planets, through you. This quiet symphony unfolds without sound, without light, without color. It is the universe speaking in the language of space-time. One of the most soothing truths about gravitational waves is that the universe is constantly being reshaped. Every ripple changes space-time just slightly, stretching it, relaxing it, letting it settle back into place. These distortions don't accumulate. They don't shake the cosmos apart. They are simply ripples, soft touches, moments of gentle motion in an otherwise steady ocean. Sometimes astronomers imagine what a collision of supermassive black holes would feel like. Two giants spiraling toward each other over billions of years. The ripples from such an event could stretch entire galaxies. The waves would flow like deep, slow tides, steady, powerful, shaping the large-scale structure of the universe. And yet, to anyone within those galaxies, life would remain undisturbed. The waves would pass unnoticed. Time would continue its quiet rhythm. There is something profoundly peaceful about that idea, that even the universe's most violent events radiate outward as gentle waves, barely touching us, yet letting us glimpse their ancient origins. When the first detection was announced, scientists said it confirmed that the universe has sound, but not sound in the way we hear with our ears. Sound as vibration, as pattern, as motion carried through the medium of space-time. Somewhere far off, two black holes may be spiraling together right now. Their orbits tightening, their dance quickening, the fabric of space-time humming softly with each revolution. Billions of years from now, that wave will reach another world circling another star, and perhaps beings there will detect it and listen to the quiet story of a collision they never saw. In this way, gravitational waves turn the universe into an enormous memory. Every massive event leaves its echo behind, drifting forever among galaxies. As you breathe gently now, imagine those ripples passing through you, not as something to fear, but as a reminder of how connected everything is. Stars collide, and their last breath travels across time to reach you. Black holes merge, and the space-time beneath your feet shifts by a fraction of an atom. The universe moves, and you move with it. You are part of its rhythm, part of its quiet music, part of the soft, eternal wave. Stellar nurseries, how stars are born, from gas and dust, in the quiet corners of galaxies. Far from the bright glare of mature stars, there are regions where the universe dreams, places where light is soft, where shadows drift through vast clouds of gas and dust, where the silence feels thick and ancient. These are stellar nurseries, the cradles where stars are slowly, gently born. Imagine drifting into one of these nebulae. Colors swirl like watercolor, deep blues, soft purples, warm reds, mixed with darkness so velvety it feels like a blanket wrapped around the cosmos. These clouds stretch for light years, larger than entire solar systems, cold and calm, waiting patiently for the next chapter of creation. At first glance, stellar nurseries appear still, almost motionless, but deep inside their cool, shadowed interiors, gravity is at work, quiet, steady, persistent. Tiny clumps of gas begin to gather. Hydrogen atoms drift closer to one another. Dust swirls in slow spirals. Over millions of years, these clumps grow denser, heavier, warmer. Each one is a beginning, a seed of a future star, a soft echo of the universe's long memory of creation. These forming stars, still hidden within the nebula's folds, are called protostars. They do not shine yet. They do not radiate. They simply warm as gravity pulls them inward. A protostar is like a heartbeat forming before the child is born, quiet, steady, full of potential. As you imagine floating near one, you might see nothing at all. Protostars stay wrapped in cocoons of dust for hundreds of thousands of years, but if you could sense the heat rising inside, you would know something extraordinary is unfolding. Every moment, the protostar grows denser. Every moment, atoms collide more quickly. Every moment, gravity pulls inward with greater insistence. And then, slow, steady, inevitable, pressure builds to the point where hydrogen begins to fuse into helium. A star is born. The moment of ignition is gentle, not explosive. There is no cosmic fireball, no thunderous sound. Instead, the star begins to glow softly from within, its light pushing away the cocoon of gas that once hid it. The surrounding dust scatters in beautiful patterns, sculpted by gentle winds of newborn starlight. A stellar nursery becomes a nursery no longer. It becomes a celebration of light, clusters of newborn stars twinkling like fresh sparks in a dark expanse. Some stars emerge small, destined to shine for trillions of years with quiet persistence. Others are massive, blue giants born with fierce luminosity, burning fast and living short lives. Some form in clusters and stay together for millions of years. Others drift apart, becoming lonely wanderers across the galaxy. Yet they all begin the same way, softly, slowly, inside the comforting darkness of a nebula. Stellar nurseries are shaped by cycles. Once a star is born, its radiation begins to sculpt the surrounding cloud. UV light pushes away gas, winds carve channels, shock waves ripple through the nebula, compressing some regions while dispersing others. These shock waves often trigger new rounds of star formation, meaning one generation of stars can help give birth to the next, like cosmic parents passing on the spark of creation. Some nurseries grow busy and crowded, producing hundreds of stars at a time. The Orion Nebula, visible even with small telescopes from Earth, is one of these bustling cosmic cradles. Inside it, thousands of stars are forming simultaneously, each one at a different stage of awakening. If you drifted through Orion, you'd see dust pillars stretching like ancient columns, glowing edges sculpted by starlight, pockets of darkness where protostars still sleep. The nursery hums with creation, though no sound can travel in space. Its beauty feels alive. Its colors feel warm. Its entire structure glows with the breath of newborn suns. Stellar nurseries can also be surprisingly fragile. A single massive star, too bright, too hot, can disrupt the balance, blowing apart the clouds with its intense radiation and fierce winds. And yet, even this destruction can spark new life elsewhere. The universe, in its gentle cycles, always finds a way to turn endings into beginnings. If you follow the journey of a forming star long enough, you'll see that the dust swirling around it begins to flatten into a disk, a beautiful thin ring of material orbiting the young star. This is the protoplanetary disk, a birthplace for planets, moons, asteroids, and comets. Inside these disks, grains of dust cling to one another, forming tiny pebbles, then rocks, then mountain-sized bodies. Over millions of years, planets assemble quietly, slowly, without any rush. The entire story of a solar system begins in these soft, dusty rings, shaped gently by the glow of a newborn star. Some of these planets may remain barren and cold. Others may become warm oceans under blue skies. A few may one day host life that looks up at the stars and wonders where it came from. In that way, stellar nurseries are not just cradles for stars. They are cradles for futures. Every nebula you see in telescope images holds within it the possibility of new worlds, new stories, new forms of life. Creation in the universe is not a single event. It is a continuous, unhurried process that unfolds across billions of years. As you breathe gently, imagine drifting through a nursery like the Eagle Nebula, where the pillars of creation rise like cosmic mountains. Their tips glow softly with the heat of forming stars. Dust cascades down their sides like ancient sand. Light filters through them in warm, amber hues. In that moment, you might feel something subtle. The universe isn't static. It is continually giving birth to new light, continually renewing itself, continually creating stars that will one day cradle the atoms of new life. And somewhere, in one of those dusty folds, a protostar is forming right now, a future sun, a future system, a future story. Stellar nurseries are the universe dreaming aloud, softly, patiently, shaping tomorrow's stars in the gentle darkness. When we look up at the night sky, we often imagine we're seeing the whole universe spread out before us. Every star, every galaxy, every shimmering thread of cosmic light. But the truth is softer, stranger, and far more comforting than that. We are not seeing the whole universe. We are seeing only a small bubble of it, the observable universe, a gentle sphere of light wrapped around us like a cosmic lantern. This bubble isn't defined by what exists. It's defined by what light has had time to reach us. The universe has been expanding for 13.8 billion years, and light travels at a constant speed. Together, these limits form a boundary around us. Beyond that boundary lies everything we cannot yet see, simply because its light hasn't arrived. The observable universe is vast, about 93 billion light-years across, but it is only a fraction of the whole, a drop of light in an endless cosmic ocean. Imagine standing on a beach at night. The waves in front of you glow under the moonlight, but the rest of the ocean stretches into darkness you cannot see. You know the water continues, but it vanishes beyond the horizon. That's how astronomers feel when they look into deep space. We see the glowing waves. We know there is more. We just can't see beyond our horizon. The boundary of the observable universe isn't a wall. It's a horizon of light, soft, fading, shaped by time itself. Inside this bubble, galaxies spin, stars burn, planets orbit, nebula flourish. Everything we have ever observed lives within this sphere. Every telescope image, every star map, every cosmic discovery belongs to our side of the horizon. But the entire universe stretches far beyond it, deeper than distance, older than our sight, unfolding into regions we will never reach. What lies beyond? The answers are both humbling and strangely comforting. Some scientists believe the universe extends infinitely, an endless web of galaxies beyond count, repeating in patterns so vast they never truly end. Others imagine the universe as finite but unbounded, like the surface of a sphere, without edges, curving softly into itself. And then there are the theories that the universe may be just one part of a grander multiverse, like a bubble floating in a sea of countless other bubbles. But no matter which picture is true, one thing is certain. The part we can see is only a small chapter in a much larger cosmic story. As you breathe gently, imagine yourself floating at the edge of the observable universe. Not a real boundary, but a place defined by time and light. Ahead of you lies darkness, not because nothing is there, but because its light is still traveling through the endless night. Somewhere beyond that darkness, galaxies are forming, stars are shining, planets are orbiting suns we will never know. And yet the universe quietly connects us all. Gravity stretches across these unseen realms. Cosmic expansion shapes both the visible and invisible parts. Dark matter threads into filaments that extend beyond our horizon. The entire universe moves as one, even if we can only witness a small part of the dance. One of the most soothing truths is this: the observable universe grows with time. Every second, light from more distant regions reaches us. Every moment, our cosmic horizon widens just a little. The universe reveals itself slowly, gently, patiently. But because the universe expands faster than light travels, some distant regions will always remain hidden. Their light will never catch up. Their stories will remain unspoken. And somehow, this makes the cosmos even more peaceful, knowing there are mysteries so far away that they will forever remain beyond reach. Imagine stars forming in a galaxy far outside our visible horizon. Their light will never reach us. Their planets will never be mapped. Their stories will never cross into ours. And yet, their existence does not depend on being seen. They shine quietly in regions of the cosmos untouched by our gaze. The universe does not need an audience. It simply exists in calm, eternal unfolding. Sometimes astronomers wonder whether the structure of the unseen universe mirrors the parts we can observe. Does the cosmic web extend forever? Do superclusters repeat in rhythmic patterns across unimaginable distances? Is our observable slice typical, or is it unique? We may never know, but it is the not knowing that makes the cosmos so soothing. The unseen universe is a reminder that mystery is not a flaw. It is a feature, a quiet invitation to wonder. As you drift deeper into this thought, imagine the observable universe as a glowing sphere around you. Inside it, the galaxies shimmer like scattered jewels. Outside it, endless possibilities stretch out, soft, silent, unreachable. Like dreams just beyond memory. The visible cosmos is our window. The entire universe is the view we cannot yet see. And both are beautiful. Sometimes, when you stand beneath the night sky, looking at starlight that began its journey long before you were born, you can feel the gentle truth settle into your chest. We are all living inside a growing bubble of light, a small, warm island in an ocean too vast to ever fully know. And yet, in that smallness, there is comfort. In that bubble, there is meaning, because the part we can see is enough to fill our minds with awe and our hearts with quiet calm. The universe beyond the horizon will continue its silent expansion, its unseen stars continuing to burn, its galaxies continuing to drift, its stories continuing to unfold with or without us. What we can observe is enough to understand our origins. What we cannot observe is enough to remind us of humility. And together, they form a universe both intimate and infinite. As you breathe slowly, imagine drifting near that horizon, watching galaxies fade into soft darkness, knowing that beyond them lies a cosmos still dreaming, still expanding, still carrying secrets not meant to be solved, only felt, a universe seen, a universe unseen, a universe whole. And as this journey through the quiet corners of the cosmos comes to a close, may you feel a softness settling over you, the kind that comes only when the mind finally loosens its grip on the day. The universe is vast, but its peace arrives in small, delicate pieces, drifting towards you one calm moment at a time. And the fact that we can meet those moments slowly, gently, in this quiet space together, that is something truly beautiful. Wherever you are now, wide awake or drifting just beyond the edge of thought, I hope your dreams tonight move like starlight across still water. I hope your body feels a little lighter, your breathing a little softer, and your worries a little farther away. And I hope you carry with you, even faintly, the memory of a universe that glows not just above you, but within you. If you happen to still be awake, you're welcome to wander into the next chapter whenever you're ready. And if you'd like more stories like this, soft, soothing, wonder-filled, whispered gently into the night, you can subscribe for more. There's always more to explore here, one sleepy soul at a time. Good night.